If you're ready to take your Python skills up a level, this is the video for you. Over the next 7 hours, I'm going to take you on an object-oriented journey with OOP programming, taking you through these advanced, crucial concepts in Python. And we're really going to focus on two key concepts: encapsulation and inheritance. This course builds on your core foundational skills so far in programming, and it's an extension of my Python for Absolute Beginners course that I released at the beginning of the month, right? It's still absolutely free. That's the best part. 7 hours of more premium content coming at you for free. If you guys enjoy this stuff, do me a favor for this course, like and subscribe to this. I know, right? But liking helps this course reach more students, people who could really use this course, and comment your thoughts below. If you've been feeling overwhelmed by this topic, OOP, right? Let me break it down for you. I've got you covered. By the end of this course, you're gonna have mastered a crucial concept, not only in Python, but in programming concepts as a whole. With over 7 years in the education space, I've created interactive lessons and materials, as well as live coding exercises. That's right, all these challenges to further your understanding of OOP. If you're ready, I've been ready. Let's dive in. Welcome to a Code with Josh special. Don't skip this part, guys. All right, the next few minutes are the most important few minutes of this course because I'm gonna break down who this is for, is it even for you, all right? And who this is gonna work best for, how to go through this course, all right? So just give me a few minutes here, right? This is my extension to really break down a key crucial concept in programming, right? OOP, or object-oriented programming. All right, now this is a topic that I did cover in my course, Python for Absolute Beginners. I'll put that here, all right? That was still free for you, right? But it's a rather crucial and advanced concept. This course is dedicated to furthering your understanding in this crucial concept of OOP through encapsulation and inheritance, all right? Now, if you're new to programming, this is not the course for you. Okay, you should understand Python as a whole already, right? Control structures, functions, modules, all right? You should maybe have worked with classes before. If you haven't, that's okay, right? Because I'm not going to teach programming, the basics of that. I've done that in my previous course, all right? Now here is going into OOP. We're going to further that. And I want to emphasize too, this is not a project-based course, all right? I do have projects in this, but I want you to think of these projects as more like challenges or scenarios as we work through and introduce you to more advanced OOP concepts. Now, guys, also, this is still 100% free, right? I'm not getting paid anything for this, but I'm hosting this course as well as my other course for you guys on my own platform, zerotonowing.com. I'm going to put that as the first link in the description, all right? Head on over there and you get a boatload of free resources for you, right? My handcrafted Python guide, you get an interactive learning community to chat with others and learn. That's key, all right? If you're going to hold yourself responsible and you want to progress and learn, don't sit here and watch a YouTube video. It's not going to happen, all right? By learning, engaging, asking questions, answering questions. That is how we learn, right? So check out the platform. It's absolutely free. It's the link in the description, all right? And that's just going to bring you guys a smoother viewing experience, right? It's still free, and so use it. All right, now this course, guys, I have timestamps. Use the timestamps. If there are topics you know, skip ahead to that topic. Indulge in it. Comment, ask questions, all right, and code along the way. All right, I'm really excited for this, right? Any questions, let me know. All the resources I have for you guys are in the description. All right, I think that's it. Over to the course. Enjoy. Hi, and welcome to the Zero to Knowing Object-Oriented Programming in Python course. My name is Josh.
with over 5 years in the education field, for which 2 of the last have been specifically with Python. I've taught teens all the way to young adults. I've taught hundreds of students, and I'm here to share my knowledge with you. Let's jump into a general course overview of what you can expect throughout this class. Throughout this class, you are going to build a strong foundation in the fundamental concept of object-oriented programming. You're going to use your existing Python skills as we grasp new concepts and you learn new ways to implement your logic. The knowledge you gain in this course is going to be instrumental in your programming journey from here on out. And as we go through our lessons, we are going to build on each previous lesson. And this is going to give you a good understanding of OOP and the general concepts that come with it. I've seen many students struggle with this topic or try to speed past this topic of object-oriented programming. This course is designed to give you a strong foundation in those important fundamentals that we will use in any OOP language. Many online courses have too much, and some of the fundamental concepts get brushed over because of too much material. All-in-one courses don't spend enough time strengthening your foundational skills. I've broken this course down to a level that's easy for you to understand. This course is structured in the best possible way, so as you progress through, it's gradually going to get harder building on the skills that you're learning from the previous lessons. Throughout this course, you will get an overall idea of what is object-oriented programming. You will spend time working with different objects, spend time defining your own classes and objects. We together will grasp the concept of class inheritance as well as the concept of multiple class inheritance. And finally, to end this course, you are going to learn about Dunder methods, or the special methods that come with object-oriented programming in Python. Who is this course designed for? This course was created for beginners to intermediate students in mind and will not teach you the fundamentals of Python, but rather the fundamentals of OOP. Students who join this class should already have a basic Python understanding, such as what are conditional statements, loops, functions, and the data structures we use in Python. This is not a project-based course, but rather a challenge-based course to really hone in your understanding of OOP concepts and the overall logic we need to solve these problems. It's designed for those of you who want programming broken down to a different level of understanding. It's designed for the visual learners as well as challenge-based learners. Throughout this course, you will have slides for our new topics, live coding exercises, as well as quizzes. I can't wait for us to get started and to take a closer look at object-oriented programming. I'll see you guys in class. Started with our course. This video is for those of you who do not have Python installed on your computer and do not have an IDE like VS Code. If you have both of those, you can skip this video and head into the first lesson. If you don't, this is the right video to help you get set up. First up, let's get Python and install that on your local environment, your system. On Google, I would like you to just Google Python. And it should be the first link, or it's going to be the first unsponsored link. I'm going to click Welcome to Python. It takes you to the Python page. Now, here is where you can find any documentation or anything to help you with Python. What I'm interested in is I want to scroll down, and we see all these subtitles. I have Get Started, Download, Docs. Today we're interested in download, and I'm going to click the latest version, Python 3.11. Now, do not worry. By the time you watch this video, this version of Python may have changed, and that's okay, because currently what I'm on is Python 3.10. As you can see, this is 3.11, so it's fine. At the very bottom, you are going to see these files. Now, it's very important here. If you are on a Mac, you are going to click the Mac Universal Installer. If you're on a Windows, you can click the Windows Installer 64-bit. I'm going to click Mac because I'm on a Mac. And then in the top, it is going to download Python. Once Python is done downloading, you need to go through the steps for installation. So open it, run it, and go through those steps. I'm not going to do so only because I already have this on my system. Great. Over in Google, we need to get an IDE. Now, you have plenty of options for this. You could use Sublime, Atom, or what I personally use is VS Code. So I'm going to go into Google and I'm going to search for VS Code. There it is. It is the first link, visualstudio.com. Visual Studio is great and it's wildly popular amongst developers around the world. If we go in here, you can just click the first link. It takes you to the home page. You're going to see a big blue button here. Now, depending on your operating system, this will change. I am on a Mac, so it tells me to download Mac Universal. If you're on a Windows, it's going to tell you to download the Windows Universal. You can click here, and then just like Python, it's going to download in the top right. Once VS Code is done downloading, you can open it and go through the steps for installation. I highly recommend that you get a shortcut and you save this to your desktop or your icon bar at the bottom of your window. As we're going to be using VS Code a lot, it'll be handy to have a shortcut. I'll see you guys in the next setup video. Hi, and welcome to the Zero to Knowing Object-Oriented Programming course. This is Lesson 1. Before we jump in and start coding or anything like that, we need to start at the very beginning, and we need to discuss what is Object-Oriented Programming, or simply put, OOP. Let's jump in. To further discuss and break down what exactly OOP is, I have made a list of bullet points. It's a way to organize our code. This makes it easier to understand, manage, and reuse. All objects, they are like blocks of code, and they each have their own properties, attributes, and their own functions. Methods. Simply put, if I could explain it like this, is objects are like building blocks or like Legos, and they can be used to create more complex problems, or if you're building with Legos, more complex designs. In OOP, there's a big word, and it's called encapsulation. And this is hiding all the internal details of one specific object from the outside. By hiding this, it makes it easier for us to manage and for us to understand the code. Then, the holy grail of OOP, we have inheritance. This makes programming with objects amazing. Inheritance allows for the creation of classes. Now, going forward, I want you to think of a class as a blueprint, and this can be used to create multiple objects with shared properties and methods. this is going to be a powerful tool as we go forward. Let's take a look at what an object really is. So, on the screen, each object, right? So I have object 1, object 2, object 3. They each have their own attributes. So in this example, an attribute could be considered color. They each look different. They have their own color, and they have their own unique actions. But at the end of the day, all of these are objects, or all of these are squares, per se. All right, so just remember, an object has its own properties, its own attributes, as well as its own actions. What can this object do? Here's a fun example I've put together. And going forward in the coming lessons, I'm going to use examples like this. Here is an example of objects. Now, they are all birds. We can see that. They're all birds, and they share some of the same properties. But then they all have unique properties of their own. So, some common characteristics of all of these objects. They all have 2 legs, and they all can fly. Those are shared properties. Some unique properties, for example, is I have a type of bird, hummingbird. This hummingbird is only found in the Americas. These are unique properties that only this bird has. So, you can see we have 4 different objects. And an object, I want you to remember this word instance. I prefer to use the word object, but in other programming documentation, you will probably see this word instance more than once. An instance is an object. It's an example from a class. So this object is from this class. Now a class is like a family. It's a group of similar objects under one roof. All of these are unique birds, but at the end of the day, they are all birds. If I asked you, what animal is that? You would tell me it's a bird. If I asked you to be very specific, what type of bird is that? Well, that bird is a parrot, and that bird is an object. This is how object-oriented programming is broken down. Let's move on a little more. I'm going to give you guys a brainstorm challenge, and I want you to take the next 5 minutes. I would like you to think of 3 different classes, remember, families, and for each class, I would like you to think of 3 objects. As an example, if I go back, I have 1 family, birds. Then 3 objects would be owl, hummingbird, canary. That's one example. I would like you guys to think of 3 more classes, each class with 3 objects. Pause the video here, write down what you come up with. Pause the video here and write down what you come up with before moving on. Great. Some examples that I've come up with, I have put in the source code for this lesson, and I've also put it here. These could be 3 examples that I came up with. I have a class, a family of vehicles, right? Each of these are a different object. At the end of the day, they're all vehicles, but when you get specific, one object is a car, one is a truck, one is a van, and one is a luxury vehicle. They're all different types. I have a class for furniture, but furniture is very broad. What are some objects that come from this class? Chair, sofa, table, bed. Finally, I had a class of countries, and then we have US, Thailand, Vietnam, and France. They're all different countries. At the end of the day, they are all a country. They come from a class, countries. Great. I would love to hear what you guys came up with, so be sure to put it in the Q&A of this lesson. Before moving on to working with objects in Lesson 2, at this point in your Python journey, you should already have a decent understanding of the following: variables, functions, loops, conditions, as well as some basic Python lingo. You can see on the screen I've made some categories. In the first one, I have functions. Now, when it comes to functions, you should understand both of these. How to define a function, and if I use the word parameter or argument, you should understand what that is too. With loops, you should know how to set up while loops and for loops and why we use both of these. You should understand our conditions and conditional statements, which means creating your own and all the logical operators that come with that. You should know some basic data structures. This could be your dictionaries, as well as lists and tuples. All of these were acquired over the fundamentals of Python, which you should have learned. Going forward with object-oriented programming, this is more of an intermediate to an advanced topic. I will be using function, loops, conditions, and data structures throughout this program. If you're unfamiliar with any of these, please look some of them up before moving on. I will see you guys in Lesson 2, working with objects. Welcome back to Lesson 2. In the last lesson, we introduced what exactly is object-oriented programming. In this lesson, we are going to begin working with objects in Python. This will strengthen your understanding of what an object is and how we use this. To work with objects, I am going to introduce a special Python module. To work with objects, I am going to introduce a special Python module. This module is called Turtle. And Turtle is a module in Python which allows us to draw and create art. But you're probably asking, Josh, I signed up for a course on object-oriented programming. Why are we doing this module? Although this seems like something for kids, Turtle module is a hidden gem for learning OOP. Throughout my years of teaching, I have seen Turtle strengthen the fundamentals of objects in my students. That is why I'm using it in this course. And this module is going to give you a strong understanding of how objects work in programming and how we can use them throughout our code. In the picture on the left, we have 9 objects, all of which are turtles. Each turtle, though, has its own properties, so its own color, and it very well may have its own speed. And they all have different actions that can do different tasks. Now, 2 new keywords that I introduced in the last lesson. What are methods and properties? Let's dive in and let's take a look. A method is a function. All right, so simply put, if we boil everything down, a method is a function. Do not forget that. Specifically, it is a function in a class. A property is a variable, specifically a variable in a class. If you have to say that a few times, that's okay. A method is a function in a class. A property is a variable in a class. I want you to think about, how do you use variables? How do you define variables? Good, got it. How do you make a function? How do you use a function? You should know those, and you should start to think about those. On the left, I have 3 different properties. I have a color, a speed, and a width. If we think of these like a variable, which you should, I have my variable, and then the value to the variable is here. So owl color, its value is maroon. Parrot speed, its value is 5. Canary width, its value is 2. Now, a property and a method must be linked to an object in order to work. So color is linked to the object owl. Speed is linked to the object parrot. And width is linked to the object canary. If you guys remember from the last lesson, I showed us an illustration. We had a class or a family which I called birds. In the bird family, we had 4 objects. We had an owl, hummingbird, canary, and parrot. And those are the objects that I am linking to my properties. Very good. On the right, I have an example of 3 methods. It looks the same as a normal function. It has a unique function name, and it's followed by a set of parentheses. Just like a property, a method must be linked to an object in order to run or work. Just what I had mentioned, right? As you can see, all my properties and all my methods are linked to a specific object. So let's take a look at how to set up our code. We are going to be heading over to VS Code or an IDE of your choosing very shortly. Now, the code on the left here is actually outputting the image that you see here on the right. You should have a basic understanding of how modules work. At the top, we are importing this module turtle. I am then creating 2 objects, okay? So an object is just like a variable, but the value of the object is a class. So T1 is an object, turtle1. The value of T1 is a class. My class is turtle. It's capitalized, and it's followed by a set of parentheses. Once I've created my objects, I can then set the properties of each object. So T1 is going to have the color of orange. T2 has the color purple. I am then linking 2 methods to each object. I am giving them actions. I'm giving them instructions of what to do next. When I run this code, we can see the output on the right. But let me break that down even further. Here we have step by step of what's happening. And this is how I like to use Turtle and create objects. We're importing everything at the top of our code. Once we have our imports, I can then create any objects I will use. I could create 1. I could create 5 as well. We are then assigning the color property to each of our objects, and then I am linking our 2 methods to the object in order to get them to move. The final function you see here on the screen is done. This is a special function that comes with Turtle. It allows the drawing to stay on the screen once it is completed. Great. I've shown you some basic Turtle code. I'm actually going to show you some of the functions, the methods, and the variables or the properties we will use in this lesson. Let's check them out. Alrighty. So on the left, I have my column of some properties and methods you will use and what they do along the way. Okay? Please note that all of these must be linked to an object because they are properties and methods. We have the color property, and this assigns a color to the object. Now, it's important to note the color inside is a string. The second method is width, and this is the width of the line you're drawing. Automatically, the width of the line is 1. If you would like to increase that, you can put an integer inside, which will change your width. The turtle is just the name for the object, and we can actually change the shape of all the objects you see on the screen. You can change it to circle, arrow, square, turtle, as well as a triangle. You can use the speed property, which speeds up the drawing itself. The maximum speed you can do is 10. In order to give your turtle motion or action, we have the forward method. You can use the word forward or you can use FD. Inside, we put the number of pixels you want to move in that direction. And finally on this page, we have our directions. We have left and right. Both of these methods take a degree. How many degrees do you want to turn left? 90 degrees would make you a square if you did that 4 times. Very good. Take a moment if you need to. Pause the video here, take a screenshot. I'm going to move on to a few more properties and methods. Here are a few more. So, we have a method called up. Now, if you imagine that your object, your turtle, is just like this pen I have on my screen. I'm drawing right now. If I want to move to a different location, I need to up. I need to pick my pen up and move it to a different location. I can use the up method to do that. I can use go to justify which coordinates I would like my object to move to. Now, this does take an X and Y position. Once we've moved to a new location, I can then put my pen back down and start drawing again. Great. The steps in order to move your object: up, go to a new position, put it back down. You can then draw again. In one of the challenges, I'm going to ask that you make a circle. Now, if you're up for a good challenge, you can try drawing a circle with just your 2 methods, forward and left. If you want to make it easier, Turtle has a circle method. Inside, you put the radius. How big do you want the circle? If I said T1 circle, T1 is going to draw me a circle with the radius of 10. Good. The final few methods, there's so many, that's why I encourage you to go back through these slides, read the documentation online, and see what you can do with your objects. If you want to fill in your drawing, which I'm going to show you shortly, but you want to have, for example, your square to be a solid color once you're done drawing, you need to use the begin fill method. We use this before you start drawing, and once you've finished drawing, you can use the end fill method. These two working together will fill in your object with a solid color. The very last line of code you should be using is done. This allows your drawing to stay on the screen once it's completed. Very nice. That's a lot of methods. I've gone through 12 actually. All right. So using Turtle with the basics of Python. In lesson 1, at the end of that lesson, I said that you should already have a good understanding of how to make functions, loops, conditional statements. All of that basic knowledge you can use right here in Turtle to hone in your skills, while now we are working with objects. So take a look at my code, right? On the left, we see normally I am importing Turtle. I then create one object, T1. Remember, an object has the value of a class. I assign my object two properties, color and width. Great. I am now ready to start doing something with my orange object. I want to fill in the shape I draw. Then I'm using a for loop. You should know how to use a for loop. I'm saying for I in range 5. That means my loop is going to repeat 5 times. Every time, two things are happening. My object is moving forward 150 pixels before it turns left 144 degrees. Once it's completed, it's going to fill in my illustration, which produces an output like this, an orange star. You can actually see my object here on the left of the screen. That is what your turtle will look like if you do not give it a starting shape. Very good. Let's take a look at that example a bit more, right? So just by using that loop, that for I in range 5, that's producing the orange star you see on the screen. If you did not use a loop, it would be very repetitive because you would have to write this 4 more times. I am saving you 8 lines of code by using a for loop, right? So experiment. Use the programming knowledge you already have and tie that together with working with objects in Turtle. Great. Taking a look at a more complex example. Don't worry, I will break this down for you even a bit more. At the top, we start with importing Turtle. Okay, I'm going to work left to right. You always start with your imports at the top. That shouldn't be anything new. Then I have defined 2 functions of my own. I made the star function and the circle function. For this purpose, I am just going to work with the star function. My star function takes 4 parameters. It takes an object. I'm going to give it a width, I'm going to give it a size, and a color. Then, just like outside of a function, t1.color, right? I'm taking my object t and I'm assigning it a property. What is the color going to be? Well, the color is going to be whatever I give to my parameters. The same thing applies to width. I'm giving my object a width. That is going to be done when I create or call my function. This code is the same exact code as you saw in the previous slide. If I go back, right here, you see all of this, except in this example, I define the object as T1 specifically. In the following example, I have defined one object, T, but T could be anything. Over in our code then, right, you can see that I have made T, so T equals turtle. I'm going to give this object to my function. Our program runs. We begin with asking for an input. This is where I can enter a shape. So if my input is equal to star, I'm going to collect a width, I'm going to collect a color, and I'm going to collect a size. This will be my arguments for my star function. I'll break it down a little bit more, but I encourage you to pause the video here and really just read through the code. You should understand 80 to 90% of this. All right, so you can see I've color-coded that. those three green variables, width, col, and size, they are being used as the arguments to my star function. Those arguments are being passed up to the star function and being used as the values within my function. The same thing is happening with circle. If I enter circle in my input, then I am asked for a radius and a color, which I am using as the arguments to my circle function. They're passed and they're used to create a circle. Pause here, give it a good look. All right, I'm about to give you guys your first challenges in VS Code. Here we are. I've put together 5 challenges for you guys. Number 1, I want you to draw a hollow pentagon. Each side of a pentagon has a different color. Number 2, draw 4 solid squares. Right, so these squares should be filled in with a solid color. All different colors, but all in different locations. How do we change a location? You might need to go back a few slides. Number 3, I want you to create 3 functions. Each function will draw something different when it's called. This is very similar to the previous example in the last slide. Go back and take a look. But come up with your own shapes. Don't use a star. Make something else. Number 4, I want you to draw 10 circles, each at a random location with a random radius. So this might be new to some of you, but if you hear the word random in Python, you should be thinking about the random module. Now this one's a good challenge because it's going to require you to import the random module and use the randant function. If you don't know how to do this, do a little Googling. And finally, your last challenge. I would like you to create 3 different objects. These objects will draw 3 triangles in a column. Each triangle is a different color. Okay? Now, as help, you can use the slides to help you. Please do. I encourage you to do that. But at this point in your programming journey, you should also be comfortable doing your own research or learning how. You can check out the Turtle Graphics Module documentation. Just Google that. It's going to be one of the first links. You can also use these slides to help you. Now, I'm going to head over into VS Code and we are going to code this out. I encourage you to try these challenges on your own. I'll see you guys over in VS Code. Great. Welcome guys to VS Code. In this lesson, we've introduced working with objects in Python. As for now in VS Code, we are going to put some of that to use and get on coding. Now, before I start coding, reminder, there are so many ways to solve one specific problem. Any way you're able to do it, well done, amazing. You should not have to do it the way I do it. If you do it like I do, great. If you find a different way, that's you being creative. That's fine too. Alrighty, you had a chance to read through the tasks of this challenge. Before watching this video, I highly encourage you to try these challenges on your own. Go back through the slides of this lesson, read the documentation for Turtle. Do your best to overcome these challenges. If you get stuck, watch the video, or if you want a guide to follow along with, watch the video too. I'm going to jump in with our first challenge. In the first exercise, I asked you to create a hexagon with 6 sides, each side with a different color. There are many ways to do this. I'm going to try and do this the more efficient way. There is a longer way. There are other ways. Choose your path. First thing we want to do is we want to import. Remember, all the imports are at the top of our code. So from turtle, I would like to import everything. That's what the star means. From the turtle module, import absolutely everything. I am then going to make an object. So for the purpose of this, let's pretend you're drawing on a piece of paper. So I'll say pencil. What is pencil? Well, an object is always equal to a class. My class is turtle. Great. I've made an object. Now, I know that each side of this hexagon needs to be different. So you could do this a few ways. I'm going to make a list. How many sides are in a hexagon? Well, there's 6, if you didn't know. So I'm just going to make some colors here. I'll say red, purple, orange. What other colors do we have? I think lime green's a color in turtle. I'm going to put that in there. I'll say light blue. I believe that's a color. What am I at? 1, 2, 3, 4. Okay, cool. Let's just say green, dark green, and then yellow. All right, we have 1, 2, 3, 4, 5. Oh, is that 7? I have 7 colors. Let's take away green. Okay, sweet, 6 colors. Now I want to repeat a task. Remembering the basics of Python. How can we repeat something? A loop. I can say for I in range. I want to repeat this, well, 6 times, right? That is how many sides are on a hexagon. So 6 times. I'm going to take my object, my pencil, and I want to change the color of my pencil. I want it to be one of the colors in my list. Specifically, I want it to start with red, then it'll go to purple and work its way through the list. So to do this, I'm going to take my list, colors, and I need to give it an index, a position. I'm going to say I. So I is the first index the first time this loop runs, right? The next time this loop runs, I will be the second element. Change my color. Let's just take this. Let's say the width of our pencil. Let's just put that at 5. My pencil can now move forward. How far? Let's say 100 pixels. And then our pencil can move right 90 degrees. Remember, the last line of code I'm going to put here is done. This will ensure that the drawing stays on the screen at the end. Great. Let's run our code. I'm going to head up there, run the code. Terminal appears. I should see a window. There we go. The window is quite big, right? So I'm seeing an issue, right? It's drawing a square. I don't want that. Who caught on? Why is it drawing a square? Let's go back to my code. Because I put 90 degrees. That's for a square. I should be putting 60 degrees. 60 times 6, that is equal to 360. That's the total number of degrees in a circle. Let's try that again. Boom. There we go. There's our hexagon. You can see that my turtle graphics screen in VS Code is quite large. That's okay. You're able to see what I'm drawing. Yours is going to be large too. So we have a hexagon, different color sides with a width of 5. One object. Pretty cool. Alrighty. I'm going to trash my terminal. I'm going to turn all of this off except my import, because I want to continue to use that for my other challenges. In our next challenge, we wanted to draw 4 solid colored squares, each with different colors, each in a different location. This is weird. This is really weird. So in order to get this going, we need to think about the word random, all right? Now, if you haven't used it before, which you should have with the basics of Python, playing with modules, there is a module in Python called random. I want that. I'm going to say from random, import, let's say random, because that's all I want. I want the random function. I already have turtle, so I can create my object. Let's say pencil again. Pencil's my object. What do I want to do? Well, I'm going to have 4 squares, and they're all going to have to generate a different color. A color can be RGB colors, so red, green, blue, with the maximum of 255. Let's create a random color for each one, red, green, and blue. So I can say for I in range, how many squares will we have? 4. I'm going to have red, green, not global, green, and blue. Let's start with red. R equals random. I can say 0 to 255. That way it's going to choose a random number between 0 to 255. Each of those is going to do that because this is going to generate us a color. Now that I have a color, I can just insert in here, and I can take my red, I'm going to divide that by 255. We can take our green and our blue. That's going to get us a nice unique color that I can use here in Turtle. Remember, there are other ways to do this, not just one. Now that I have a color, we want to define and create some location. Our locations are always going to be X and Y. So a random location. The left of my screen is going to be negative 200. The right can be positive 200. You should already have a good idea of how coordinates work, and this should not be a new topic, right? But that's generally going to keep it on my screen. I can go left 200 or right 200 with 0, 0 being the exact middle. Every time I draw a square, remember, how do we move the pencil around? Well, I need to take my pencil and I need to lift it up. Once the pencil's up, I can take my pencil and I can go to a new position. Where do we want to go? I want to go to my random X and Y that we just created here. Once I've gone to that new position, I want to put my pencil back down on the paper. Great. Pencil's in a new position. We are ready to draw the square. So, to draw our square, pencil, let's change the color to the color that we just made. Our color argument right here is this one. That's a random color. We can then begin fill. Remember, if we want to have a solid shape, we use begin fill at the start, and we will use end fill at the end. Great. Now that I'm in my loop, we can go forward 100. This time, I can go right, RT, right. You can also spell right. And I'm going to say 90, much better. Once we've drawn that shape, I would like to end my fill. The last thing we're going to do is say done. Right, let's run that code. We have one object. This object, oh, there we go. Okay, so I have been given an error. It's really coming from line 35, and all of this is being triggered. So what I'm going to do, let's color equals. Cool. Let me give that a whirl. See what I'm working with here? There we go. Boom, 1 square. Okay, 2, 3. All decent locations. It looks pretty cool. I have a lightish blue one, a mint green, raspberry color, and a gray square. That's the job. That's what we were trying to do. Random squares in a different location with different colors. If you really wanted to take this challenge up a notch, You could have done random sizes for the squares too. Think about that. How could you implement that in your code? Try and find out. All right, I'm going to close this, trash my terminal, and I'm going to turn off this code here, all of it. Okay, let's go down here. We are now going to move on to the next challenge of working with objects. You should start to begin to feel comfortable with what an object is. How do we use it? Remember, pencil is the object. The value of an object is a class. And the class has all these special functions and properties that come with it. Pretty cool. Number 3, we wanted to create 3 functions that each will draw a different shape when they're called. Functions. You should know how to make a function in Python. That was the fundamentals of Python. If not, this will be a quick refresh. Now remember, I already have, I'm just going to comment it out, from turtle import star. I already have that at the top of my code, so I'm going to skip that part. I'm going to come right back down, and we can create our object, pencil. Now I'm going to make some functions. So what shapes do we want to draw? Why don't I draw a square, a circle, and a pentagon? Those are all good shapes. So I'll make a function called square. Square is going to take really 3 parameters. It's going to take an object. That can be my turtle, my pencil. It's going to take a size of the square, and it's going to take a color. Now that I'm in my function, I can do exactly what I have been doing. So I'm going to take my object and I'm going to set the color of this object. So my object is T. T color. The color that I want it to be is whatever my color parameter is. Let me change this. I'm going to say P for pencil. That is going to make it easier to understand. So I now have the color that this square is going to be, and I'm going to call begin fill on my object as well. I can now go through the normal steps for I in range of 4. Remember, I'm drawing a square, and I want my pencil to go forward. How far? 100? Well, you could say that, but we have our parameter size. Whatever I enter as an argument for my function, that is going to be the size of my square. If I enter 50, cool. My square is going to have a size of 50. All right. Then I'm going to say right. I'm going to start to use these other words now, as I don't want to get too shorthand for you. That's going to get confusing. So object, pencil, is going forward, the size amount. The object is going to go right for a square, 90 degrees. Great. At the end, what's the last thing we need to do here? Well, I began the fill. I now want to end my fill. Cool. Just to kind of show you guys what's happening, I'll put that in here. I'm going to run the code real quick. I'm not done by any means, but let's just watch what happens. I call my function. I give it my object, pencil. I give it a size, and I give it a color. Let's run it. On my screen, we are going to see that red square appear right there, and it's filled. Now you noticed it cut out real quick, because we should have done as the last function here. Let me run it again. Cool, great. I know it's working. That was a quick test. Let's close that, trashing our terminal. I'm going to turn off that function I called. I'm going to make my circle function. So circle is also going to take an object. It'll take not even a size. It's not going to take that. It'll take a radius, and it'll take our color. So I can say color is our color, right? Very good. Keeping that the same convention. I'm going to call the turtle circle function, and I will give it my radius. Now, even before that, that's just going to draw a plain circle. So let's say begin fill here, and we can end with our end fill. Cool, that is our circle. While I'm here, I'm just going to make our pentagon as well. Pentagon, objects, size, and the color. The same things as the other two functions. I can start with my color. I'm going to go to my begin fill. Then, because it's a pentagon, I'm going to make a for loop. What's the range? 5. It's going to be 5. Inside that. There we go. Okay, so every time my object is going to go forward 100, my object can go left. You can say right, because up here I said right, left, right, up to you. Let's say left for that is actually going to be 72. Great. A part of the challenge, I want a way that I can call these functions more uniquely than this. So I'm going to make like a loop. And my loop, I'm going to be able to enter as an input what shape I want to draw. Pretty cool. So let's say start is going to be an input. And in here, I can say a few things. I can say square, I can say circle, or I can say pentagon. And I'm going to make sure that they're all lowercase, linking.lower. While my input is not equal to, I don't know, let's say stop. While input is not equal to stop, if my input is equal to square, so if I've entered square, I want to collect some information here. I want to collect a size, and I want to collect a color. So I'm going to say size is equal to an integer. Enter a size. Color, because colors in Turtle are a string, I can just say enter a color as a string there. Then we will call our function. I'm going to give it an object. What is my object? Pencil. What is my size? Well, I'm going to use my input size, and my color can be color. Nice one. Done. I'm going to add an also if circle in there. If circle is called, I don't need a size. I need a radius. So I can say radius is our input, right? I will just say enter radius. I'm going to copy color because that's not really going to change. We need a color for circle. Then we will call our circle function. Let's give it our objects. Let's give it our radius. And let's give it our color. Nice one. Okay, that brings us to our last shape. So let's make one more elif and say also if our pentagon was called. What I can do is, because I'm going to use a size and color, I'm going to take what we said here from our square. The only difference is I'm going to call the pentagon function, give it a size, give it a color too. No good conditions completed without an else. So I haven't put any warnings in here. I don't have any exceptions. So let's just say else. Anything else, I'm just going to say error, shape not found. Good. Do you guys remember? What's the last thing we need at the end of a loop? Well, a loop needs a way to break, to escape. A while loop can go on forever. We don't want that. That's a problem. So you need to be thinking about ways to break that loop. The one way to break it is I can just take my input, copy that, and I'm going to put that at the end of my loop. That way, every time my loop runs, it's going to ask this question again, and it will check to see my input at the start of my loop. Nice, we've done a lot. Go back, read through the code. Most of it should be familiar. If there's something that's not familiar with you, really break that down. If you need to watch that part of this video again, do so. Run your code, experiment with it. And let's see what happens. I'm going to run this code. I'm going to make my terminal a bit smaller. I don't really need that. Cool. So as you can see here, I need to put this over here. Turtle's still on the screen. At the bottom of here, I'm seeing square, circle, pentagon. So I'm actually going to enter, and I'm going to say circle, enter, radius. Let's say 25, color blue, enter. I'm going to go back here. There we go. I have a blue circle on my screen. Nice one. Okay, let's go back. I'm going to do pentagon. Pentagon, enter. Size, 150, color orange. Going back. Oh, there we go. Ah, all right. So I did not begin and end fill with the pentagon. It's not doing anything with that. Let me fix that. But let's do the square first. Square, enter, 100, purple. Oh, what did I do wrong? Shape not found square. Okay. Ha, spelled square wrong. So I fixed that. Before I move on, let's just go to pentagon. Let's just say p.endfill. Trash my terminal. Reopen our code to get it working. There we go. Let's go into our code. Let's do pentagon this time. Pentagon 200. Purple. There we go. Great. Now it's filled, right? So I can now type whatever I want. And whatever I type is going to be drawn onto our screen. Oh, matched perfectly. That's cool. I'm going to type stop. That is going to break my loop, right? So then our code is done. Now, very, very nice. I'm going to turn off all this new code, right? So what I'm doing here is I'm touching on all the topics that were introduced in the fundamentals of Python. Now, you might not be a master at these topics, but by going through them now, you're learning two things. One, how we work with objects, and two, how we can use our fundamentals of Python to build while working with objects. Great, guys. I'm going to head over to the next video. We are not done with these challenges. I just want to give you guys a chance to review what we've learned. In the next video, I'll be back here in VS Code, and we will finish up those final two object challenges. I'll see you guys in the next video. Great, here we are in the last video for working with objects, where I'm going to finish up the final two challenges that I've given you guys. In the next challenge, we need to draw 10 different circles, all at a random position and a random size. I love random. All right, so I have turtle. Let's just go up here from random. Anytime you hear that word random, think the random module. I'm going to import everything. Great. Let's make our pencil. So our pencil, that is our object. The value is our class. What I'm going to do here is I only want it to go when I enter something into input. That way it's just not going to, it's going to wait for me to start. So let's say like start. You don't have to do this part. You can just do a for loop. So I'll start with that, and then I'll go back to what I wanted to do. How many times will we repeat this? 10. The challenge is to draw 10 circles. Every circle needs something. It needs a radius. If you want to do a random color, that would be a really good challenge. I'm not going to put that in here though. So radius is random. Literally pick anything. I could say 5 to 100. Let's say 5 to 100. I have a random radius. I need a random x. We will keep with the statistics of negative 200 and 200. And I need a y, like so. Okay. We have everything we need to start drawing. What I'm going to do is I am going to take my object, so pencil, pen up, or up, right? Either of those two work. I'm going to keep with up. I want to pick my pencil up. I want my pencil to go to a new position using the x and y that I've created here, right? This is a random value. This random value is being used for my x position. Our pencil can then go back down to begin drawing. All we need to do to draw a circle, quite handy, quite useful. We saw this in the previous exercise. Take our pencil, call the circle method, and I am just going to call radius. Radius, that is the input that we collected up top here. It's going to be a random radius. Awesome. Let's run it. That's all we needed to do to get this working. When Turtle loads, it is slowly going to go through, and you can see they're not being filled in. I didn't ask you to fill them in. I did ask you to put them as a random size, all in random positions. And by saying negative 200 and positive 200, it's keeping them all in that general area. Nice. Really cool, guys. I'm going to say done. So I used one object from a class, and I used that object to draw 10 different things, or do 10 different things. That's great. Okay, if you wanted to, right, I could say like start, and I could say input, and we could say while start is not equal to off, then all of this is going to go, and we could take our input, put that at the end. The only difference this is going to do, right, is it's going to do that. I need to enter something, anything, right? So I could say apple. It's going to go back. It's going to start drawing. By using that while loop with input, it's just waiting for the user to tell Python to do something before starting. Additional things from the fundamentals we can use with objects. All right. That brings us to our last challenge. Our last challenge. I love this one. We want to create 4 different objects. Each object is going to draw a triangle, but these 4 triangles need to be in a column. Each triangle is a different color. Ooh, what can we do here for this one? So first thing I want to do is I want to create 4 different objects. So far, we've just been working with 1, but I can create multiple objects from the same class. And that's what I want to do here. So instead of saying pencil, I'm going to go shorter. I'm going to say T1. I'm working with turtle, so turtle 1, turtle class. Turtle 2, turtle. I'll fix that. And T4 equals turtle. Nice. So this is going to pair well going into our next lesson. I have 4 different objects. Remember, each object has its own data and can do its own thing. What I'm going to do in order to do this, now you could have made 1 object, right? The thing is they won't all go at the same time. You will need to wait for 1 object to draw and then go to a new position. I know I'm going to draw a triangle, so let's create a function for triangle. My triangle is going to take one of those objects, one of those turtles, as an argument. It will also take a color, right? So what I can do here is I'm going to take my object and I'm going to call color, give it a color, right? I can say begin fill because these triangles are going to be a solid color, and then we will do our for loop. Triangle has 3 sides. Our range is 3. Every time our turtle is going to go forward, let's say 100, and let's say left. Ooh, what is our left? It's not 90, it'd be 120. 3 sides in a triangle. 360 divided by 3 is 120. T and fill. Very nice. Our function is done, which is great. I want a way now that I can iterate through and I can draw these triangles at the same time. You could be thinking of different things, and you may have already solved this problem. What I like to do is I love loops, and I love to iterate through things. So I'm actually going to make a list called T, right? And I'm going to put all my objects in this list. And for the purpose of this, let's call this turtles. Can I do that? Turtle, that's better. Let's say for every turtle in my list turtle, I want to do something with the turtle I'm on. So the current turtle, that's T. I want that turtle to go up. I want that turtle to go to a new position. Now, I want them to be in a column. So the X, that's not going to change, but the Y is going to change. I need a way to change my Y. How can I do that? Well, we could create a counter variable, right? Let's say Y initially is 100. That means the first turtle is going to go to X 0, Y 100. My turtle can go back down on the paper, and then it would do something, right? But now the next turtle needs to go to a different position. Let's change the value of that Y variable, and let's say Y minus 100. So every object, T1, T2, T3, T4, is going to go to a slightly different Y position. Are you with me? Pause it, read through, see what's happening. Now, the final things we need to do. I really just need to call my triangle function. I'm going to say T1, let's say blue as the first color. I'm going to say triangle, let's say T2, let's say red. Let's say triangle, let's say T3. Give me a color. Let's do purple again. And then triangle, T4, excuse me, and we will say blue. Did I do blue? I've already done blue. Green. There we go. Who remembers the very last line of code? Done. Wow. You've done it. Let's run it. Let's see what's happening now. Boom. You see 4 different objects on the screen too. That's amazing. They're all in a perfect column. Nicely done. If you got any of these challenges on your own, you're off to a good start and you're going to do well in this course. If you found some of them quite challenging, that's okay. Just know that this course might be a bit harder than you initially expected. Try to spend some time reviewing the fundamentals as you go through this course, such as functions, loops, and conditions. I'll see you guys over in the next lesson. In the next lesson, we are going to start to define your very own classes and objects. I'll see you guys there. Hi, and welcome back to Lesson 3 of the Zero to Knowing course. In the last lesson, I introduced the topic of objects and how to work with objects in Python. In this lesson, we are finally ready to define our own classes and objects. If you remember from Lesson 1, I said to think of a class as a blueprint. This still applies now, especially going forward. A class is a blueprint. Let's jump in to this lesson. If I were to break it down, so as I mentioned, a class is like a blueprint, or it's a template for creating many objects. So on the left, I have a sketch or a picture of a house. And this sketch is our class. It contains a general overview of this type of object, or it contains the general information you need in order to make an object. On the right, we have a completed object, and this is what we created from the class using a description. An object of a class. Now, I want you to kind of remember from the last lesson. Do you remember this? T1 equals turtle. I want you to say that 10 times if you need to. Get really annoyed by it. T1 equals turtle. T1 equals turtle. T1 is an object. The value of an object is a class. Turtle is a class. So here I have my instance or my object. The value of an instance is my class. Now remember, a class is always capitalized. It is one of the very few things in Python you capitalize. A class is followed by a set of parentheses. Capitalized parentheses. Let's take a look at a few more objects. So, here we go. You remember from the first lesson, I introduced a class of birds. Well, let's take a look at a few more examples. As you can see below, these are all objects, or they're all animals, right? At the end of the day, it doesn't matter. In English, all of these are animals. That is our class. They all have additional properties or actions of their own, right? So the owl is the outcast object. It is an object, it's an animal. It has its own name, has its own abilities, has its own properties. Okay? Next up, we have 3 land animals, let's call them. And they share 2 of the same properties. Each of these objects have 4 legs and a tail. But they each have their own properties, such as the type of animal and location as well. How many objects do we have? 4. How many classes do we have? 1. Our class is animals. Our objects are owls, raccoon, lion, and giraffe. Let's take a look at another. So here, they are all phones sharing some of the same properties. They all have some of the same properties and actions of their own, but then they all have their own unique as well. Creating a class. Before we create any objects like a raccoon, a lion, we need to create a family. We need to create a class. In this class, this is where we define all the unique properties and all the unique methods that our objects will have. But first, we need to look at an important function. This function is called a constructor function. But really, it's called our constructor method, right? What is a method? A method is a function in a class. And this special method is automatically ran when an object is created. It creates an instance, it creates an object of a specific class. This word constructor, what does it look like? Constructor looks like construction. What is construction? Build. We use the constructor method to build something, to build our class. This method is called init. Okay? Now you can already see init looks weird. You've never seen this before. It has 2 underscores in the beginning and after init. That's very important. Okay? We must use this as our constructor. This is always the first method in our class. Init just means to initialize. Initialize just means to start, right? So every time we start our class or we create an object, we automatically use the init method. Creating our class. We're finally here. All right, we're starting to see some actual code come together. I'm going to break this down for us. If you need to rewatch any of this, please do, because this is a very important topic, object-oriented programming. So on the left, we have all of our code, and you can see that I'm starting at the top with my class. To define a class, we use the class keyword. And then we give it a unique name, just like a function, but the first letter is capitalized. Then all the code inside is just like code outside. You would make a function the same way, but this is a method. Why is it a method? Because it's a function in a class. Our first method is our constructor, init. Init is taking 1, 2 parameters, just like a function takes parameters. These parameters are the value to my properties. At the end of our class, I make an object, car. The value of an object is a class, my class in this example, right? Remember, T1 equals turtle. Well, my T1 is car. My turtle is my class. I am giving my class 2 arguments because init has 2 parameters. That's very important. I can then use my drive method and I can link it to my car object. If you're a little confused, don't worry. I'm going to break this down even more. But before I do, you see a new word on the screen. What's that new word? Boom. We see the word self. This is very important. We use the word self in a class. Now self, it's basically a key, okay? And it unlocks the class so we can use all the properties and the methods anywhere we want throughout the class. Self is a key. You must have it as the first parameter in any method, okay? But it's important to note that you never use the word self outside of a class. All right, let's do some color coordination now. Okay, here we are. Pause the video, okay, if you need to. Just use the color coordination to help you. All right, so at the top of the screen, the first thing I do is we create a basic class. I named it my class, okay? Up next, the first method in our class is our constructor method. This is where you will define all the variables, all the properties you will use throughout your class, okay? Each parameter is the value to one of the properties. Next up, we define a method named drive. This method, this function, uses the values from our two properties and gets the sum, right? So I have a variable x, and the value of x are our two properties added together. I can use my properties because I am using the word self. Remember, self unlocks our variables and functions to use them throughout the class. Finally, at the end of our code, I create an object named car, and then I give my two arguments to my class, 50 and 60. 50 is parameter 1. 60 is parameter 2. I then link my drive method to my object, and this is how we call a method, because a method must be linked to an object. Right, here we go. So when I call my drive method, the output in our terminal, it would say the speed is 110 kilometers per hour. Okay. As you can see, I added on a little extra there, right? But because my two arguments are being passed up here, they are the value to my parameters, I can then use my properties, which I'm adding together here, and then I'm converting that integer to a string, which is being printed out inside our terminal. Pretty cool, huh? Everything's starting to link together. This is good. All right, let's take a look at another class. Okay, so I want you guys to pause the video, read through the class, okay? I have two questions on the screen at the bottom. Try to answer those before I do. All right. I have a class called app. You can see that's created at the top of my screen. Here's app. The first method is our constructor. I am creating three parameters: users, storage, and username. For each parameter, I am creating a property. And remembering the value of my property is my parameter. That's all init is doing. It is a place to keep, create, and store our variables we will use in the class. I then have two methods. My first method is login. This is just a normal condition. If username, if my property self.username is equal to owner and self.users is greater than 1, then I can print off welcome username, your storage is the amount of storage. Right, so right here, what is it going to print off? Think about that. Then I have a method called increase capacity. Increase capacity is its own method in my class. It takes one of its own parameters. I can use my property self.storage, and I can add that parameter to it before I return self.storage. So, were you able to answer my questions? What is the name of my class and my objects? Well, let's take a look. Okay, our class is app. Our objects, we have two, product 1, product 2. Remember, the value of an object is a class. Go find that. Now, my next question for you guys, at the bottom of the screen, what are the value of my properties? Pause it, answer it. There we go. The value of my properties are my parameters: users, storage, and username. Self.storage is equal to storage. Next question, bottom of the screen. Where are the arguments that will be given to my class? Right there. These are the arguments. Remember, in order, right? It's very structured. Users, storage, username, users, storage, username, right? In that order. These are being given to my class. Wonderful. Okay, so here's a breakdown. I took that same class, right? And all we're doing is we're going top to bottom because that's how we design our blueprint. Remember, our class is like a blueprint. We design the blueprint before we create an object, before we create the finished product. We create a class called app. Our method login has a condition which checks the properties against a set value. That set value is owner in the integer of 1. We create a method called increase capacity, and all this does is increases the current value of our property self.storage. Then finally, once we've made our blueprint, our class, we can create an object called product1 or product2, and we can call the methods we want. Okay, so here's even a bit more, right? I've kept a few of the hints from the last slide, but I've added a bit more. In the new ones I've added, we set up our constructor with the properties we will use throughout this class. We have a method that increases the value, right? And then we have our product2. What is this going to output? Well, let's take a look. If you haven't guessed it yet, which your mind should be ticking, your wheels should be spinning, what will this be outputting? Well, let's start with our first object. Our first object was product1, right? And product1 is taking the arguments 35, 256, and owner. When I call the login method, those are the first 2 lines. It's going to say welcome owner, and it's going to say your storage is 256. Then I also called the increase capacity method, and I gave it the argument of 50, which is being used as my parameter. It's going to take my original storage, which was 256, and it's going to add a number to it. That updates our storage to 306. If I take my second object and I call the login method, it's going to show login denied. Why? Well, my username is Josh. If username is equal to owner, do this. Otherwise, login denied. So my name was not owner. Login was denied. Great. A lot of things happening, right? So go back through these, read over these, see what's really happening. Once we get to VS Code, it is going to start easy, but I'm going to give you a few challenges, and it's going to get harder rather quickly. It's meant to challenge you, and it's meant to help build you that strong object-oriented foundation in Python. Before VS Code, let's take a quick flashback to what you were learning before objects. Here we are. A class is a big group of methods, and each method contains various elements that you've already learned in Python, like conditions, loops, lists, dictionaries, and more, right? So everything you see on my screen, you should feel fairly confident with. If you don't, I think you should stop now. You can go back to Turtle, because going back to Turtle, you will reinforce your understanding of objects, but you can also reinforce and practice your understanding of the basic Python programming concepts, like conditions, loops, and functions. A quick recap. A condition is really just if something is true, do this. Otherwise, do something else. That's what a condition is. If this is true, print hello. Also, if name is Josh, print it's me, Josh. Anything else, print goodbye. That's how a condition is set up. A while loop literally translates to while something is true, keep repeating. If it's not true, stop, right? So in my loop, while count, while input is not equal to 0, keep repeating. Every time I repeat, I'm going to ask for a new input, and I'm going to check if my input is 0. It's going to keep repeating, right? Our for loop, if I literally translated a for loop, which I do that, for every item inside something, I want to do something with that current item, right? So I have a list, ages, 1, 2, 3, 4, 5, 6. If I take my loop for every age in my list ages, if that current age is less than or equal to 17, I'm going to remove it, right? So my loop is going to go 33, and it's going to take 33. If 33 is less than 17, nope. My loop is going to keep going, and it's going to check every number. Oh, it gets to 15. If 15 is less than 17, that's true. It's going to do something, right? You should feel very comfortable with these. All right, let's jump in and check out some challenges. Do not go back. Okay, this is our first challenge in VS Code where we are building classes. This is a point where we should try to avoid going back from. And I want you guys to try to recreate the code from the previous slides and use it as an example to build your own first class in VS Code. Now remember that this class has one base class, and I called it app. Inside app, we had 3 methods: init, login, and increase capacity. Login checked if the username was equal to owner. If it was, it printed off welcome as well as the value of your storage. Increase capacity allows us to add a number to the current storage. Finally, create 2 objects, and both of these objects call both methods. Head over to VS Code, give this challenge a try, and I will see you guys there for the next few challenges. I'll see you in VS Code. All right, great guys. Here we are in VS Code. In this lesson, we have introduced the topic of defining your own classes and your own objects. And that's what we're about to do here in VS Code, is to strengthen those foundations and build on what we have been learning. In this first challenge, I asked you not to go back, and I wanted you to try to create the app class from the lesson here in VS Code. In this video, that's exactly what we're going to do. So, coming up top here, we can use the class keyword to define a new class. I'm going to call this class app. Now, remember, our class is capitalized. Everything after is inside the class. What's the first method we need to make? Who remembers? What's that special constructor method? Well, it's init. Remember, init means initialize or start. And the first parameter inside any method is the word self. Self acts as a key, and it unlocks everything for us to use around our class. What were the other three parameters? We had users, we had storage, if I can spell correctly, and then we had username. For each of these, I am going to make a property. So self.users equals users. Self.storage equals storage. And self.username equals username, like so. Very good. Our init is defined. The first official method we had was login. So I can make login. Remember, give it the key so we can unlock it later. This condition checked to see if the username was owner and to make sure we had at least one user in the system. So I can make a condition and I will say if username, but if self.username, right? Because a property, it's just like a variable. It's the same thing. But because we're inside our class, in order to pass this variable around, we need to use the word self. So our variable is called self.username. If self.username is equal to owner, and our self.users is greater than or equal to 1, we would like to print off a few things. The first thing we can print off is welcome. Then we want to print off the username. So I can say welcome username. Then I would also like to print off how much storage they have available. Your storage is, let's just say, and we can say self.storage, like so. Very nice. A condition doesn't need to have an else, but most of the time I like to put one. What would you like to happen otherwise? And we can say you are not a user. Nice. That method's done. Now remember, a method is not the same as a function. If I call a function like this and I run my code, I'm going to get an error because this function is a method. It's a function in a class. It tells me login is not defined. It can't find login anywhere. I want you to think about why as I finish out this class. Great. Our next method was to increase our storage capacity. So capacity, there we go. First word is self, but then we're going to give it an additional number that I can do stuff with. I want to increase my existing capacity. So I'll say self-storage plus equals that new number. Great. I can then just print something like updated storage. And we can just now do self.storage. That's our new number. Very nice. Before I create that bonus method, I'm going to just create our objects. So let's say product1 is equal to app. Let's say their users, they have 35 users, 256 gigabytes of storage, and their name can be just like the video, let's say owner. We can then call our methods. So the reason login didn't work before is because a method must be linked to an object in order to work. So product1 login, and I'm going to say product2 increase capacity. Let's say 44. That should give me an even 300, right? I'll make one more now. I'm going to print off an empty space first. Then we can do product2 is equal to app as well. Product2 can have 12 users. They can have 128 gigabytes of storage, and their name can be my name, Josh. For each of these, I'm going to say product2.login what's going to happen there. And I can say product 2 dot, I don't want to upgrade it. Let's just leave it for that. Let's run the code. Great. Now we're going to see a few things happen here. So, awesome. The first part, so 1, 2, 3, that's really being printed right here, right? Welcome owner. My name is owner. So if username owner and users is greater than 1, it's printing off these two. Then updated storage. Remember, I'm increasing my capacity. So I've changed my storage from 256 to 300. Very nice. In our last one, it just tells me I am not a user because I do not meet these two conditions. Nice one. Let's jump into that bonus real quick. I asked you to have a bonus, right, that would check your upgrade. So I'm going to call this check upgrade. And check upgrade does not take any parameters. It does take self, right? If our users, so let's say if users is greater than or equal to our storage, then I need to upgrade my storage. So I'll say upgrade amount. So I can collect an input of how much do I want to upgrade it at. I'm running out of space for the amount of users I have. So let's just say here upgrade amount, like so. All I want to do then is I can say self.storage plus equals upgrade amount, like so. Cool, very nice. That will upgrade it. And then what I want to do then is else. So if I do not need to upgrade my storage, if I still have enough space, I want to print how much storage do I have remaining. How can you solve that? How much storage I have remaining? Well, let's print off, and I'm going to say something like you still have, then let's do here, I need to do a math problem, right? So I need to do self.storage minus my users. But I want to make sure that this is a string. So I'm going to convert that to a string. Then just close off your string and say, I don't know, spaces open, like so. Nice one. I'm going to come down here for product 2, and let's say product 2 dot check upgrade. I want to see if it's time to upgrade. Run our code. Nice. So it says you still have 116 spaces open. Why is that? Well, 128 minus 12 is 116. That's exactly what we did here. 128 minus 12. Incredible, guys. I hope you have followed along this far. Let's head over into the next video and start with challenge 2. I'll see you guys there. Here we are in challenge 2. Now, I'm not going to read all this, as I'm hoping you guys already have and you've broken it down to what we need to do. But I am going to read the overall description of what we are going to be building out in this class. The code we make, it's going to represent an online course management system. We're doing an online course. This will help us keep track of online courses, students, and their grades. And it allows us to do things like add new students, see the course details, and it's going to allow us to calculate the average grades from our students. This is a lot, okay? So I want you guys to try to work through this one by one. Don't do everything at once. Do small tasks to work into this big problem. What's the first thing we need to do? Create a class. What's the first method? Make your constructor method, right? Step by step. All right, heading into task 2, I'm going to start out with us coding this. I will build a class called, let's call it online course. That's what it is. We will build our constructor method, giving it our key of self. What information do we need here? Well, initially all we need is I need a course, like the name of a course. And then I need like who is teaching it. So an instructor. So in this course it'd be me. In the course name it would be 0 to Knowing Object-Oriented Programming. These two parameters I am going to create our property for. Remember, every parameter we have, we would like to create a property for. Okay, instructor, close enough. Nice. In the last one, I'm not going to give my init this method, but remember that init is a place we keep all the variables, the properties we will use in this class. So I can make a variable here too. I'm going to say self.students. Now this is going to be a list that I can use throughout my program. That's all it is right now. Great. Your first method that we needed to make was a method to add students to. So the first method we needed to make was a method to enroll students. Let's just call it enroll students. Now, it's going to need who. Who do we want to enroll? Well, that's going to take a name, right? It's going to take a student's name. And what I want to do is any student who is enrolled, I want to add them to my list, right? Remember the list we just made here? Self students append. Who do we want to append? The student name. Very nice. Once we have enrolled a student, I want to print off their information. So to do this, I'm going to use in Python. You might know this, you might not. You might have seen this in other languages. In Python, it's called an F string. I'm going to use an F string here because I just want to keep everything nice and easy and keep it all together so I don't have to use commas and pluses to add different types of data together. This just makes it more convenient. I want to print off the name of the student. So Bobby has been enrolled in the what course? Self.course. Bobby has been enrolled in the science course. Right? The name of the course would be printed there. Nice. That's all we're doing for enroll. We add a student to the list and we just print off and say, hey, this student is now a part of this course. All right. Our next method is, let's say we want course details. I want the information about a course. So it's not going to accept anything. It's literally just going to print off detailed information about our course. So here we can print. I'm going to use F strings for all of these. So the course name, and then our course, we can just say self.course. We are going to print off here, and in this print, we can just print off the instructor name. Let's say instructor name, and we can tap into our property, self.instructor. And then in the last one, what I'm going to try to do is I want to print off all the enrolled students in the course. Now, you could just print off the list, honestly. I could just literally go here and just say self.students. And that's going to work. There's nothing wrong with that, right? If you wanted to get a bit more creative, I could do that. And let's add in here, and let's say I'm going to put like a comma, right? Because each name is going to be separated by a comma. And then I want to connect. I want to join, right? And we haven't quite touched on this yet, right? I'm going to use the join method. What do I want to join together? I want to join together my students, like so. All right, so I'm given an error. Okay, let's do this. Let's change the double quotes. Let's put single quotes, as our outside ones are already double quotes. There we go. Okay, so now it's going to join together in one line. Now, there are going to be new things that I drop in this course here and there that I didn't talk about in the lesson. But that's okay, because as you're now in this part of your programming journey, you should understand that certain things you might need to Google or research or find somewhere else. And if you're able to do that, that makes you a stronger developer. I've made a method for course details. Let's call that done. Okay, nice. I'm going to make a method for completion. Or just call it completed course. So like, who completed the course? When I say who, it's going to need a name again, right? So if the name I'm checking for, I want to see if it's in my list. Because if it is, I want to remove that student from my list. They are not a part of my course anymore. So if that name is in my list, I can use a condition with my in operator. Then I want to remove that student from my list. Very nice. I can just print off, and you could say something like course completed. If they completed the course, let's say name has completed the course. That's cool, okay. Else, let's just print off, and we kind of need to like warn the user, and we basically need to say that the name you're looking for is not even a part of the course, is not enrolled in this course. Nice. All right, we've made 3 methods, right? We're building on everything we've been learning. That brings us to our last method, guys. Let's do one for average grade. It's going to take self. This needs to take multiple grades. What could that be? Well, that's going to be a list. I've actually given you a list too. And you should know how to find the average of something as well, right? You don't need to be amazing at math for programming. Honestly, you don't, right? The computer can do that for you. But you should have some basic understanding of math. And this could be just algebra in general. So how we find the average of something. So to find this average, I'm going to create a variable called total. And I just want to add together my list. So I can use Python's built-in sum function to do that. And I'm just adding everything together. Now that I have the total, we want to create an average. And the average is going to be the total divided by the length of our list. The total divided by the length of our list. Okay? Now that we have our average, we can just go through. You can print off anything you want to say. The average grade is, let's just say that. Let's just put here, and I'm going to say average. Awesome. In the beginning, let's do a few things here. Let's make this more unique. Let's say course input. Let's say name. And let's say student. Right? Because this is how a real program would run, unless we're coming from like a database. So let's say input. Let's say enter a course. I'm going to make sure everything's lowercase. Okay? That's just good practice. Let's say enter teacher or instructor, right? Instructor. That's what we want there. Lower. And then the last one you can say enter a name. because the last one is for our student. So we can just say enter a name. Dot lower. Nice one. Okay. We've been done with our class. These three inputs will be used as the arguments for our class. So I can come down here. I can say create an object called course, and this is equal to our class. Our class needs our class just needs 2 arguments. It needs our course name, which is course input, and it will need our instructor, which is name. The grades I've already given you, and this is going to be a list. So 90, 85, 92, 78, and 80. It's our list of grades. We can use this. Now we can go through, and I want you guys to call all 4 methods that we've just made. So take our object course. I'm going to link that to average grade, and I'm going to give that my list grades. I'm going to take my object, and I want to enroll a student. Who do I want to enroll? Well, I can enroll this into here is going to be enrolled in my course. I can take my object, and I can get my course information, the details, right? Let's just run this for now, actually. Enter a course. Python. Instructor, Josh. Name of a student, Billy. Nice one. The average grade is 85. That's the average from the list. Cool. Billy has been enrolled in the Python course. Oh, nice. All right, that's going up top here. Course Python, instructor name Josh, student's Billy. It's printing off the basic course details. Nice. I'm going to call the last method here. I'm just going to use my name, actually. So I'm going to say course completed course. I need to give it a name. So I'm actually going to say name, hard code this because I don't have this in the system. I'm going to say just Josh for completed course. So we'll say Python, Bob, instructor, Billy. There we go. So I'm using my name hard coded, and it says Josh is not enrolled in this course, right? Because, well, I'm not enrolled in the course. If name, if Josh in list, remove. Else, and I'm not removed. Nicely done, guys. That was your first challenge without anything from the lesson that we tried to implement on our own. Very nicely done. I will see you guys in the next video for our next challenge. All right, wonderful. Welcome back to our next challenge. If you haven't noticed, this is actually the code from the previous challenge, which in the text file for this one, I included as a hint to bring in that code as we're going to use it. What we want to do in this task is we want to redo and extend parts of this class. I want to be able to have multiple students, and each student is going to have 3 grades in order for us to calculate them. Now, we can go to the bottom of our class for now, because until we continue, I don't want to add anything else. You can see that I've saved my inputs and my object course from the last challenge. And from here is where I want to extend onward. When my program runs, after I'm asked for course input and my name, I want to be asked for, let's say, num students. I would like to see how many students are going to be enrolled in this class. So enter number of students. Very nice. I'm then going to create a loop, and I'm just going to say for this, for I don't even need to say I, for in range. I'm not going to use the index for anything. I just want a loop that's going to repeat for however many students we collected through our input, right there. Every time this loop runs, we're doing two things. We're asking for a name. So who is the next student we are adding to the class roster? Enter a student name. For good practice, let's make sure that's lowercase. Then we're going to ask for grades, but before I ask for them, I want to create where will these grades be stored. Currently, it's going to go into a list. Now that I know that, we can loop through. How many grades do you want? I initially said 3. You can change this. For this purpose, I'm going to keep 3. So in range of 3. Every time this loops, we are asking for a grade, which is going to be an integer. So int input, we can say enter a grade. Like so. Then we can take our grade and we can append it, add it to our list of grades. Great. So imagine the loop runs one time. The first time the loop runs, it's collecting all this information. As a matter of fact, every time our loop runs, it's collecting this information. A name of the student. And for that current student, it is going to collect 3 grades and add those to a list that's linked to that student. Nice. Okay, where do I want to keep this information? I have 2 items, but for a list, I can only add 1 element at a time, and that's a problem. If I have 10 students, each with a name and a set of grades, I need to keep them together somehow in order to add them to our list. To do this, we will create a class to store this information. I will say class student. Now, this class is nothing except like a database. It's going to hold a name of that student, and it's going to hold a list of their grades. For each of those, I just need to create a property for where they are going to be held. Like so. I have my 1 student. Why don't I take the information I collected and create an object called student? The value of my object is my class, and I'm going to give my input student name as the name and my list of grades as the grades. Nice. I can now use this student object, and I can use it as an argument in the methods from our initial online course class. I am just going to say here, I'm going to call course. That's our initial object. Right? So I'm back up to here. And for course, let's enroll students. Who do I want to enroll? I'm just going to say student. Right? That's my object right there. I can call my course object, and why don't we say average grade? I can say that, and we'll give it a student again. Then at the end, let's get our course details. So all the info about the course. Great. You can see in those 2 methods here at the bottom that I've passed in the student object, which we created here as the argument. Nice. Before I run my code, I'm going to need to go up and make some adjustments to the methods that we have built. How do I use a method? Well, that's a serious question. A method must be linked to an object in order to work. We know this from the lesson. Here is my method. It's linked to my object course. How do I use a property? Well, a property is the same way. I need to have the property linked to an object, which I need to do. I have an object student. Student has 2 properties, name and grades. When I want to access these, I need to link them to my object student. So let's go up to enroll students, and I'm going to start right here. So let's change my argument to my object. All right, so I'm going to be giving it an object student. That object student is what I'm going to now append to my list. It's the same thing as before. When I print off who has been enrolled name, it needs to find name, who. Remember that name is a property in my student class. So I'm going to say student object dot name. That's going to unlock the name. All right, nice. Let's come down here to course details. Right here, it's joining together every name in my list, but we've changed our list from names to objects. So I'm gonna refactor this. I'm gonna change this. I'm gonna say print enrolled students. Then let's make a loop. And let's say for every student in my list self.students, I want to print the current student, their property name. That'll print every student we have enrolled. Good. Okay, coming down, completed course. Let's go in here and do some things. So our completed course, we give it a name. Let's loop through our list. And let's say for every student in our list of objects, students, right? I'm gonna do a few things here. If my name, so if the current student's name is equal to the name that we gave as a parameter, then I want to remove that current student. Right? So I give this method a name, Josh, for example, for every student in my list. If the current student in my list has the name Josh, then remove that student from the list. That's what's happening there. I can then print off my name, good, and I don't actually need this else anymore. I'm just going to bring this print right there. So it's going to print as soon as the loop ends. If no students in that list, that prints. Nice. All right, then refactoring our last method, our average grade. We are going to do a few things here. So all we really need to do is we need to access these grades. Remember that that's a property found in our class right here. Our average total, same thing. Student.grades, and then our average. That's it. That's done. Good. So we've used what we built in the last challenge. We brought it in here. And this was really useful as it taught us a few things. It taught us how we can use another class as like a database. It taught us how we can access these properties from another class or outside of this class. And it also showed us how you can refactor your code to either extend it, add more functionality, or just refactoring in general. Really nicely done. Let's run this. I'll go through this briefly. Course, we can continue with Python. Josh, number of students, 2 students. Let's say Bobby has a grade of 5, 5, and a 3. Cool. So it has Bobby has been enrolled in the Python course, average grade. Asks me for another student. Let's say, cool. Asks me for another student. Let's say Emily. Emily has a grade of 5, 5, 1. There we go. Gave me her information, and then at the end it printed off the enrolled students, Bobby and Emily. The one thing I don't like is all these decimal numbers. So in our average grade function, our method, let's put in the Python built round function, and let's just round it down to 1 decimal. Great. Nicely done. I will see you in our next challenge. to our next class challenge. Before I get started in coding, I'm just going to go through and I'm going to read our description. I'm assuming at this point you have already read the challenge and gone through it, and you're ready to jump in and get started. For this challenge, we are going to be provided code that represents travel planning in a cost calculation system. It allows you to input the country you want to travel to, the month of travel, the type of travel. So, is it leisure or business? The system provides information about the trip and calculates the total cost based on flight expenses and any additional costs you may have. Great. You know me, I love travel and I love making code around travel. So I'm going to head over into our code. Here we are. So let's get started. The first thing I want to do is I want to make my class. So using our class keyword, I can say travel. And inside here, our class travel must have our constructor method in it. What properties do we need? Well, I need a country. We are going to have a month, and then we're going to have like a type of trip, right? So what type of trip? Leisure, business, right? For these three, let's create a property for each of these. Okay, so country, we have month, and month is actually going to be an integer, right? The type, so I can call it type. Is equal to type. That's fine. There we go. And the last one, I'm going to make a variable here, or I should say property, for a price. Initially, the price is 0, but once we start adding flights and other details, that's going to change. Very nice. Our constructor is all set up. I'm going to create a quick method for all the info relating to my trip. So what info should we know for this? Well, a few things. I'm just going to check and determine when the user is going. If they're going on a holiday during the winter months, I want to alert them and say, hey, they're going on a trip to this country in the winter months. So how could we do that? Well, if our month is greater than October, equal to October, and our month is, let's say, less than or equal to March, which is 3. That's why I converted my property to an integer. If that's the case, let's do a few things. So I'll put an F string. I'll say you are going to country in the winter. This is a style trip. So inside here, you are going to self.country. And then inside here, we can say self.type, like so. Cool. Okay. Also, if, let's say, month is greater than March, and our month is, let's say less than October, because that's where we're at. I can just copy my print statement. I'm going to put it here, and instead of winter, let's just say summer. Just in case there's an issue, I'll say an else, and I will say, I don't know. Let's say invalid input. There we go, invalid input. That method's done. It's just providing us the information about our trip. You should have gotten that one. If you did, nicely done. Let's form a new method, and this method is going to be responsible for calculating the cost of our trip. We do need something though, so I'm going to give it a cost as well, all right? And this cost will be added on to our current price property, right? So if I give it 10, I'm going to add 10 to our price property. And our costs, all of them will be held in a list. We want this method to repeat as long as cost is not 0. As long as you are entering a number, it should be repeating and it should be increasing our property self.price. Right? So every cost, we're adding it on to that. every cost I am going to also keep track of in my list, so I can add it to my list. And when the loop finishes, we should be collecting a new input, right, to test against our expression again. So I will say enter another cost, like so. Cool. All right, that's all that one is doing currently. All right, very nice. Now, before we can complete that method, we should be doing a few things here. When the loop breaks, okay, I am going to call another method, which I'm going to get to later. So I'm going to put a comment here, and I'm going to say let's just say call next method for now, right? And then I'm going to want to call check method. I'm going to make a method like check. In order to do that, I will need to return two things. Let's just say two things for now. Let's call that method done. Okay, I'll come back to that. I'm going to create a method called advice. Now, based on how much money I have, is going to recommend me the type of trip. If I have less than 500, I should probably print off and do something like, let's just say low budget. Cool. Let's say if the number that I give this, okay, if that's over 500 and that is less than, let's say 1500, then I'm going to print off here. And we could say for this, that's a medium budget trip, right? So take a flight to anywhere, ... Great. And then anything else, which means you're over 1500 essentially. Let's just say luxury trip. Nice. I have advice. That's going to give me my advice. Now, my last method's interesting. So I can't exactly budget how much I need for the trip, right? Because anytime you go on a trip, you know the overall cost, right? Flight, accommodation. But the one thing you don't exactly know is how much you're going to be spending per day on food. You could go to one place and get coffee for €2. You could go somewhere else and get dinner for $8, right? And it changes depending on where you go. My next method, I want to basically kind of create a way to like average and get a good estimate of how much I'm going to be spending on this trip. So I want to inspect my list that I made up here. Okay, so I'm going to give this method that list. And really, let's say less than 10. Any number that's in my list that's less than 10, I'm going to do something with that. So to begin, I'm just going to say for I in costs. For every cost in costs, if the current cost is greater than or equal to 10, then I'm going to take my counter and I'm going to increase it by 1. Great. Anything else, right? So once that loop runs, basically, okay, if a cost is less than 10, I'm adding 1 to this, right? Every time you go out to eat, right, coffee, $2, a burger, $8, a drink, $3, all of those are less than 10. That's 3 items. I want to add those 3 to this counter variable less than 10. My loop breaks. I can now say if that counter variable is less than or equal to 10, okay, I'm just going to take my price and I'm just going to add 100 to it. Right? That's giving me 100 for my food budget. And I'm just going to go in here, I'll put an F string, and I can just say updated price, and let's just print off our new price. Right? It's better to have extra money than not enough money on a trip. Alrighty. These 2 new methods we just created, I want to use them inside calc cost, right? Because these two are going to be called based on how much money I have for this trip. So let's do a few things. I'm going to create a variable called advice. This is going to basically call my advice method. Remember, to access a method, you can do so. Just use self.method name because we're inside of a class. Great. Advice is going to take a price. So it's going to recommend you advice based on the price of your trip. Nice. Let's say inspect, and let's do the same thing. Let's do list inspect method, and here I can give it my list, costs. Brilliant. The last thing you need to do is you need to return advice and inspect so we can see those results. All right. Wow. Nice work. Our class is done. That's it. Okay, pretty cool. Outside of our class now, we need a location. Where are you traveling to? So enter a country. Cool. I actually want to capitalize this. Let's get it looking all nice. Let's say capitalized. Okay. Let's say trip type. I can also enter an input here, and we can say leisure. If I can spell leisure correctly. Or business. We can also capitalize to make it look nicer. All right, so I have a location that, what am I missing? Month. So remember that we don't need to do int input because month is going to be converted inside our init function. Enter a month. I have month. Now all we need to do is we need to jet set. So I need to create an object. I need to go travel, right? So let's just say test. Okay, that's my object. And that's going to be our travel class. What are we giving to our class as our arguments? Location, trip type. That should actually be month, right? So I can say month, just like so. Great. As a test, let's take our object and let's call our trip info method. Let's call that and see what happens. I have 2 commas here. Enter a country, Vietnam, business, month, 5. Ooh, nice, there we go. You are going to Vietnam in the summer. This is a business trip. All right, looking good. Let's now do some flight cost calculation. So a flight cost is going to be, let's say, an integer input. You could do float, right? So enter flight cost. Nice one. And then we're going to take our object and we are going to, so calc cost. Change text to say test. There we go. And inside here, we can put our flight costs. All right, let's run it one final time. To a country, I will do that again. I will say Vietnam. For business. Month, the same. I know a flight cost, a return ticket to the US for me, is probably about 24 million, so $1,000. Enter another cost. Okay, I have now entered my method that's collecting the costs, right? So I have a flight cost, 1,000. Now I can enter all my other costs. So for example, let's say accommodation, 500. Eating, 5, 4, 3, 1, 2, 8, 10. Done, 0. There we go. So it's triggered 2 things. Advice, it tells me luxury trip, right? And then for our list inspect, it gives me an updated price, right? And it adds an extra 100 onto our initial price, right? So we basically just created a mini system to help us plan a trip and organize the cost. Great, guys. Feel free to move on to the next lesson if you're feeling confident. We have just completed working with classes in this lesson with 4 challenges. But if you're up for it, I've prepared a bonus challenge for you. Head over to the next video if you want to check that out. I'll see you guys there. Welcome to the bonus challenge. If you're here, you must be ready for a good challenge. I hope you are, as we are going to touch on a few new things, and this one is going to be the most challenging of the prior 4. Now, I'm going to read our description here, and then we are going to jump into our code. This code we're trying to create, it's going to be a guest management system with a loyalty program. So I want you to think about hotels or airlines. It allows you to input information about guests, like their names, their ranks, and their ages. Their rank is like how high are they in the loyalty program? Are they a gold member, a diamond, a platinum, something like that. The system provides various functionalities to retrieve guest information, track loyalty points, and calculate average guest age. Nice. This one's going to be fun. Let's head over to our code. So we know we want a class, and we know that we want a name, rank, and age. So I'm going to start with that and build that out. Let's say guest. So I'm going to go here. We will go to init self. I'm going to just say last, first, rank, and age. For each of those, let's create our properties. So I'll actually call it last name, last. First name, that'll be first. And you can see that last, I missed my T. There we go. My ranks, for the purpose of what we're trying to build here, I'd like them to be integers. So I will convert that. And age we can do the same thing with. If we want to find the average, I'm going to need that to be an integer form. All right, very good. Our first method, let's create one which is going to give us all the basic information about a guest. So like who they are, their age. And this, we are actually going to give it a list of guests. If I have 10 guests, then I will have 10 elements in my list. And I want to print off the basic information about each guest. So let's just say all my guests are going to be given here. And I can say for every guest in my list. We're going to need a list for this. Let's make one. I'm just going to call it all guests. There we go. So for every guest in my list, all guests, I would like to print off a few things here. I'm just going to say self.first, self.last, name, I should be saying. And then for our age, I'm going to do age, but let's just make it look kind of nice. Let's say age, and let's say self.age. So for every guest, print off all their information. Very good. Okay, going forward, we want a loyalty program. So I want to keep track of who are my gold guests. That's important, right? And this will also take my list of guests. Like so. So when I call this method, I'm giving it a list of guests. And I want to see who has a higher rank. And if their rank is high enough, I want to add them to a gold members program. So To start things off, let's just create a local list. So like gold members. This is our list. So anyone who meets a certain condition is going to be added to this list. And let's say a gold member must have greater than or equal to 10 loyalty points. If they do, they will be added to this list. Great. So I want to basically take each last name of my guest and I want to add them to this. So I'm going to take self.lastName, right? That's the last name of my guest. And for every guest in my list all guests, they are being added to this. So currently, my list gold members is a list of every guest's last name. But I don't want that. I only want them to be in this if they have at least 10 points. What can I do for this? Well, at the end of my list, I'm going to say if my rank is greater than or equal to 10, they will be added to this list. I'm going to type that out for you guys because these list concatenations, they are quite challenging. So breaking them down is actually easier. So the first thing I do is I create a list for any member, any guest who has more than 10 points. Okay, so any guest who has more than 10 points, or who, let's change this again to meets certain conditions. There we go. For number 2, so the second thing we do is for every guest in my list, add their last name to the list. Okay? And then the last thing we do is, so this condition must be met. There we go. In order to be added to this list. Okay, so that breaks it down for us. All right, we have this new nifty list. So let's clean that up. So if gold members is true, what do I want to do? Well, the first thing I want to do is just naturally, I'll print off a header that says gold members. Nice. So my header. Then for every member, that makes sense, in my list, my new list, gold members, I will print off their name. Now, let's do something a little fancy. Let's say I want to tab their name in. It's going to say guest. Then it's going to say the guest's name, their last name. Great. All right, that was a lot. If you stuck with that, great job. Re-watch that last 5 minutes of what we just did to break down how this list was generated, which is a faster and more efficient way to make lists. Going on to our final method, we are really just getting the guest's average age. So, yeah. Taking self, and we're going to give it our list of guests again. Okay. Now, I'm going to create a counter variable. Initially, the total age is 0. Every age in our list we're going to add on to this, which I can then use to divide to calculate my average. Let's make our loop. For every guest in my list of all guests, my total age counter variable, I want to add the self.age. I want to add the age to my counter variable. Once I've done that, then I want to get my average age, so let's just say average age, is equal to. Now, I need to calculate that. So taking our average, and I'm going to divide it by the length of my list, all guests. That's us finding the average. Then we can print off something nice like your average grade. So average, customer age, not grade, excuse me. Customer age, there we go. Then we will just print in our average age. Our class is done. It's just got those 3 methods in there. At the end, outside of our class, we're going to do a few things here now. So we will create an input for, let's say, number of guests, and this is our integer input. We can use this for the range. So enter a number of guests. There we go. So for I in range, we can enter our number of guests input. This is going to be interesting here. So every time my range loops, I want to ask one input. And through one input, I want to collect a name. I can do it like this. I want to collect a first name, a last name. I want to collect a rank, and I want to collect an age. These will be entered as one, and they will be separated by a slash. From this single input, I want to make a list, and that list is going to have 4 elements: first name, last name, rank, and age. How do we make a list from an input? Well, we can use the split method. And I want to split everywhere I have a slash in order to make my list. Okay, now that we have a list, I want to add this to our other list of all guests. So all guests is like our parent list. One element in that is going to be a child list of data. So all guests, like so, I want to append. What do I want to append? Well, I want to append an object. I want to append an object guest. Right? So I could do the same thing, right? And if I make this longer, which let's do the same thing and say guest is equal to guest. So guest is our object. It's created every time our for loop runs, and the value is our class guest. Our class, if we go up and look, it needs 4 arguments: last name, first name, rank, and age. The last name is the first element in our new list called data. So I'm going to say data index 0. That's the last name. Data index 1. I'm going to say integer data index 2. And I can say int data 3. Right, so I'm taking the elements from my list. If I were to make a very quick list, let's say first name, okay, that is going to be John, comma, Doe, comma, rank, 8, comma, age, let's say 45. So data 1 is targeting John. So data 0, that's the first element of my list, is targeting John. Data 1 is targeting Doe. You see how we were creating that from our data list that we made here. Right, so this is the same thing. Very good. Now, I do have first, last, rank, and age. Let me change this to match that. First, last, rank, and age. Okay, very nice. Now that we have that, we are done with our loop. On the outside, I want to create a starting point. So just where is my loop going to officially start? So I'm creating a variable, and the value is the first element in my list, all guests. Now that I have an object, right, remember that we are going to append our guest, and guest is really an object. I can take my object and I can link my methods. So loyalty points, program is what we call it. And I'm going to give it my list all guests. I can take my object and I can get the guest info. We will give it our list. And then I will get the average guest age, which we did call guest average.
That was it. Giving it our list. Very nice. Okay, let's run our program, see what we have happening here. Enter number of guests. I will say 3 guests to show us. First name, last name, rank, age. Okay, so John/Doe, rank 5, age 45. Enter. Our second person, let's say Jane Doe. She has a rank of 10. She's a loyal customer. She's 33. Our final one, let's say, is Josh Wenner. Score of, I get a 15. I'm a loyal customer. And let's say 25. Enter. Look at what we have going on there. I have a few things we want to look at. So not a whole lot's happening, actually. It just printed off John Doe 45, average customer age 45. Now that's because we have our object, our class, guest. We need to target the properties which are in guest. Remember, our properties are up here. So because we're passing a list, this list just has objects. So for each object, we need to access the properties for. We need to go through our class. And instead of like self.name, which was our initial property, okay, we need to go through and I need to link my object, guest, right? Because we're passing the list as the parameter, we need to access each element, and each element is an object. Each object has these 4 properties. Great. In our gold members, I'm going to do the same thing. Okay, we are going to say guest last name. Instead of self.rank, we can say guest.rank. There we go. Going down to our age, anywhere we have the word self, we're really just going to say guest. All guests, that looks good. Let me try and run this again. I'm just going to do 2 people this time. Guests 2, John Doe, 8, 45. Jane Doe, she is a 12, she is 33. There we are. Now we have a finished product. We have gold members, and it prints off John Doe, his last name. Or excuse me, it's probably Jane Doe, right? Because Jane has 12. They have the same last name. It prints off the guest information, and then it prints off the average customer age. Great, you just made a reservation system, right? Like a loyalty program. Very nice. That was our bonus challenge. We have introduced classes, how we work with classes in this overall lesson. As we head into the next lesson, we are going to talk about a new topic of class inheritance. I'll see you guys in the next video. Hi guys, and welcome back to the next lesson. In the last lesson, we looked at defining and creating your very own classes. Now, in this lesson, we are going to continue on that path, and we are going to look at class inheritance. But first, let me ask you, what do you think of when you hear the word inheritance? Well, chances are, it's probably the same for Python too. Let's dive in and take a look at some things we already know. So, a few things we already know, right? We have on the screen 3 classes: computers, animals, and games. Within these 3 classes, we have currently 3 objects, right? So MacBook, Windows, and Linux, they all come from the same class. They are all computers. Or for games, there are many types of games, but at the end of the day, they're all games, right? So in our example here, computers is a class or a family, while the 3 others are objects.
Now, I could create a class for each type of computer as well. And this would take key data from the parent that I could give to the child. That is the topic of this lesson. So here we are, we have our class car. You can see 4 objects. Each object has 3 properties. So in our first example, we have this red car. I believe the type of car from a long time ago is called a Roadrunner. That's the type. And then the other 2 are color and wheels. Now you can see each object shares 2 of the same properties, color and the number of wheels. But the type of car for each is different. We have 4 objects, all coming from a single class. But what if I said we could change that? What if we could make a child class and give it the attributes of this car class? Well, we can. In this example, I have a class called Vintage. Let me move me up just a little, right there. A new class is named Vintage, and this inherits the car class. This is our example of class inheritance. So as you can see here, I have a new class, Vintage. Vintage, inside the parentheses, is taking an argument. This argument is our other class, car. So it's really inheriting everything we created in the original car class, all the properties and the methods. I'm going to go back very quickly. As I do, I want you to keep an eye on the Roadrunner, right? We saw that in the last class. If I go back, you can see the properties of the Roadrunner are the same. I have type, color, and wheels. That's a vintage car. I'm going into our new child class, and you can see that I brought Roadrunner with all the original properties. Now I have 3 additional objects. All of these objects are a part of the vintage class, but they also have properties from the original car class. In this vintage class, we have 1 new additional property. You can see here at the bottom, price. This is only applied in this child class. Let's break this down even a little more. So we've learned a new class, we have our 4 objects, and we have 1 new property in this child class, Vintage. That new property is a price. We are inheriting our main class. Now you're going to hear me start to say some new terms. Anytime we inherit, the class that we do inherit, we can call that the superclass. The superclass is being given to other classes. Pretty cool, huh? All right. We are going to talk about 2 paths, 2 routes to inheritance. Superclasses and derived classes. Now, you're going to hear me say 2 things. I like to call a superclass the parent class, and a derived class a child class, because a child inherits the properties of their parents. The same thing works for classes. I've put a few examples on the screen. So I have all Audis are cars, all dogs are animals, all sofas are furniture, and all jeans are pants. All of those are true, right? Now, if I went to my animal, I could make a very special class for dog, and I could have dog inheriting some normal attributes from animals that most animals share, such as legs, hair, right? There are many attributes that all animals share. that would come from our superclass, animals. For dogs, what can a dog do? Well, a dog can bark, right? That is only a dog. We have two routes to inheritance. Route 1, the class is given only new methods. So it's only given new methods. We do not create any new properties for this class, which makes inheritance extremely easy because we do not need to create our init method, that constructor that we learned in the last lesson. If we do not have any new properties, we do not need to create an init for our child class. We can use the superclass's constructor function. That's route 1. Now, in route 2, the class is given both new properties as well as new methods. Anytime you create new properties, we need to make a new constructor in that child class. And we must also activate the superclass as well. And I'm going to show us how we can do both of these in this lesson. So, going back to our first slide of this lesson, we saw something similar to this, right? But now I've redone it. Computers, that's going to be our superclass. And our derived classes, all the children, will be Windows, MacBook, and Linux. They are all a class which inherits main properties and methods from the superclass. Games is also the same thing. It could be considered our superclass. We have an RPG, a racing, and a single player. They are all styles of games. They could be a child class inheriting everything they need from that superclass. Pretty cool. All right, I'm going to head over to the next video where I'm going to break down the first path to inheritance. I'll see you guys over in the next video. All right, amazing. So far in this lesson, I introduced the general idea and concept of class inheritance. Now we are going to take a look at the first path to class inheritance. And route 1 is inheriting everything from our superclass. Let's take a look at some code. Creating a child class that only needs new methods. That's a key takeaway from this. It only needs new methods. We are not giving it any new properties. When we make an object, an instance of a child class, our superclass, that init is automatically called and used for our child class. On the left, I have my superclass, main. You can see I have an init, function, as well as one other method. Then I am creating my child class. My child class is inheriting my superclass. You can see there is no new properties, only new methods. Pretty cool, right? Let's use some color coordination now. You can see that main is being inherited from that superclass. And then our properties, so for example, self.property1, I can now use that anywhere I want in my child class because we are inheriting those from that superclass. I don't need to make those all over again. I can use them as I would. All right. You can see now I've gotten a bit more complex. I've taken our example and I've now put in some live code. We have our superclass, main,
and we have one method in that class, UserInfo. Our child class is UserScore. It's inheriting that superclass, as well as creating two of its own methods. The first method, calcScore, is using the property selfAge from our superclass. And our second method, checkAge, is also using that same property. I'm creating a child class called underscore, and this will be a class which uses all the superclass's properties. Some color coordination, right? So everything in green, right? That's coming from the superclass. I don't have to rebuild. We can continue to reuse. Great. Amazing. All right, great. This was route 1 to class inheritance. Before we do any coding, recap what we just did. And we're going to head over to the next video, and we are going to check out the route 2, the path 2 to class inheritance. I'll see you guys in the next video. So far in this lesson, I have introduced the concept of class inheritance as well as the first route to class inheritance. In the first route, we did not create any new properties, but oftentimes we want to have new properties associated with a child class. This is the second route to class inheritance. In this route, we are going to look at something called the super function. Let's dive in. Here, when creating a child class, we are still passing in the superclass as an argument. And old and new properties are used in this child class as well as new methods. So I have my child class, UserScore, we are inheriting main. The constructor in this child class we have is right here. And you can see some new things are happening, specifically right here. What is going on here? What is this? Well, super is a powerful function. Super allows us to inherit not just all the methods, but it also allows us to inherit all the properties from our superclass. But we use the super function when we also want to introduce new properties that are only a part of our child class, such as score. This was created right here in this child class. Let's take a look, break this down even more. This is a bigger concept. So, everything in green, that's coming from our superclass. Everything in blue has been created, and it's only linked and found inside of this child class. Remember that super is really allowing us to inherit both the properties and the methods, but it's also allowing us to create new properties. I've put all this in green. So inside our child constructor, the first 3 parameters are actually the parameters we are inheriting from our superclass. We can then follow that by making any new properties that this child class is going to have. Pause the video, screenshot the video, look at what's really happening, and if you need to, try and take notes of your own to show this, to encapsulate this. What is the topic that I just introduced? Why are we using super, and how can we use super? Right, so here we go. When we create an object of the child class, remember
that the superclass constructor in it is automatically called because we are using super. This is basically like saying super activate. If I create a child object, it calls my child init constructor, which then calls my superclass constructor as well. Here is our example. So I took some of the example from root 1. Our superclass is main. Main has 3 parameters. What are those parameters? Name, age, location. For each of those, I have created 3 properties, which you can see I'm using throughout the method in my superclass. Heading over to our child class, user score, we inherit that nifty superclass, and then we are also inheriting our properties. I'm going to move me down for this slide. In our constructor of the child, we first pass in the 3 parameters which are found in our superclass. We are basically activating those. We then are free to create any new properties that we want that are only found in this child class. I can use these new properties or the old properties just like I would any variable. Okay, so I've color-coded this, broken this down. Take a look. I love the colors. They are all linked to each other. Right? So our child class inherits main. We also need to tell Python and activate the original properties before we create any new properties. You can see in my method, checkAverage, that I am accepting a list as a parameter. I can then use that list within that method's code. Finally, at the end of our code, I have a list called testList. I have an object called user, and I am calling my checkAverage method with that test list. In the output of our terminal, we would result in 5. Amazing. All right, let's head over into VS Code. I've prepared some good challenges for us, and we are going to build on our class inheritance. I'll see you guys in VS Code. Great. To kick things off for our first challenge, this is going to be Route 1 for class inheritance. So, as we looked at in our description, I'm going to have a class animal. And this is going to hold all the info about our animals that we want to know. So, it's going to have a region, an animal type, right, like our species. We could have a color. And then I am going to want to know, is the animal dangerous or not? So I'm creating a property here soon for lethal. For each of these, go through and create a property. So we have our 4 properties set up, and the only thing we really want this method to do is I want to just get a basic animal bio. So information about the animal. And let's just kind of call this like our animal passport. So it's like the information about the animal. For each animal, I want to go through and let's print off all 4 of those properties with some basic information. So an animal is going to be found in, we can put self.region, right? How would you like to structure our self.animal type? Let's say species, self.animal type. Let's jump in there for the animal color. Let's just say color, and we can say self.color. And then our last one, let's say dangerous. And this is going to be a Boolean value. So it's going to return either true or false. So self.lethal.
Great. Our superclass is completed, right? So now I'm going to create a child class, a derived class. For this child class, let's call this like, I don't know, a clinic. And it's going to be given all the animal's details, and we are able to search through those details and find a specific species or region, something like that. So I'm going to inherit animal. Now, this, because it's the first path to class inheritance, is not going to have any properties of its own. Therefore, we do not need a constructor in this class. Our first method can just be called animal. Let's call this one animal info. Keep them different. All animal info is going to do is it can say this is a, then we'll do self.species from region. So self.type, no, not type, excuse me, self.region. And then over here, let's do this as a, so animal type, like so. Very nice. Then our final method is I'm going to kind of call this search. Let's call this search. And what I want to do is I'm going to give this method an animal, so a type of animal. And more specifically, I'm going to be giving it a list of animals. I want to go through this list, and I want to find all the animals that are in a specific region of the world. So when this method is called, I'm going to be asked for a region. So let's say here, input, and I could just say enter a region. Let's make sure that's lowercase to prevent any of our errors. And I'm going to go through and I'm going to say for every animal in my list animals, if the animal, the current animal dot region, is equal to region. Animal is my object, and I'm linking the property region, which is created up here in our superclass animal. So if the current object's region is equal to the region that I have just input, I want to do something with that. And I'm just going to print off, and I'm just going to say species, because I want to know which species are found in that location. And I can say animal type. Nice. Okay. My classes are done. Now, on the outside here, I am going to create a new list. And this is the list that's going to be given to my search method. Right? And I want to be able to continuously add animals. So if I say, hey, there's 5 animals, I want to add 5 animals as objects to this list. Now, what we can do is I'm going to create a variable called amount of animals. And that is going to be an int input. So how many animals? Enter number of animals. Like so. Nice. For I, well, this we don't want in it. Int for I in range of the amount of animals we have. Every time this repeats, I need to collect the basic information about an animal. So I need a region, I need a species, I need a color, and I need lethal, which I'll do a bit differently here. Then I will create an object. So let's say animal is equal to our animal class. Okay, so I'm creating an animal for that. Great. So region, let's just take this one, enter a region. It's going to be the same. Species, let's say enter a species. Color, we can do the same, enter a color. Now, lethal's strange. So lethal's going to be a Boolean value, and it's only going to be created, well, right here initially. So I'm not going to say enter this. I'm going to say, let's say, is it dangerous? like so. So that's a yes or no question. So lethal is going to be true if the input is equal to yes. Lethal will be true. Great. Creating our object. How can I structure this out? Well, let's just pass all of our inputs in. So region, animal type, which I called species here. We have color, and then we have a Boolean of lethal. There we go. Finally, I can take my animals list and let's append our animal. And let's just change my spelling around here. There we are, looking good. All right, so our loop's done. If I add 5 animals, they will be in my list animals. Great. On the outside, let's create our object of clinic, which should be fine. That's equal to our class, clinic. Now for this, I will need to give it a few attributes as well, so let's just start off with region, animal type, color. Who does the clinic currently have? Let's just say Asia. Let's say tiger. And let's say color of orange. And let's say lethal. Yeah, we can say true for that. Very good. I am now going to call all the methods we created. So I'll take clinic. My first method is animal bio. So I'm going to call animal bio. Great, so I've called animal bio. Let's call our other two. So clinic dot, we have animal info, and then we have our clinic, and then we have our search, which I can call. And search will take my list of animals. All right, looking good. Let's go through and add some animals in. Let's say there's 2 animals we want to add to our list. The first animal, I'll enter the region. I will say America. Let's say a bear. Let's say a brown bear. And let's say, yes, it's dangerous. Our second animal, let's say Asia. Let's say snake. Let's say green. And it is also dangerous. Awesome. What is happening here? Well, when I made my object clinic, I gave it Asia, tiger, orange, and true. That's being printed out as my animal passport, which is the method I made in my superclass. Then we are calling our animal info method. This is a tiger from Asia. Finally, we called the search method, giving it a list of animals and then being asked for an input. What's happening in the search method? Well, for every animal in my list animals, if that current animal's region is equal to the input above, I would like to print off that animal's species. And let's change this. I'm not going to do self.animalType anymore. I want to take my object animal and do animal type. Great. I'm going to run this, Asia. Now, it's still saying tiger because we need to rerun the application. So trash can, I'm going to go up and run this again. Great. Let's do 2 animals very quickly. I'll go through America. Let's say bear, brown, yes, region, Asia, species, snake, green, yes. Enter region now, I'll say Asia. There we go. Our species was snake because that was what I was looking for. That was found in that region. Amazing. Nicely done. Great way to kick things off while working with class inheritance. I'll see you guys in the next challenge video. Welcome to the first challenge of class inheritance. In this kickoff challenge, I've decided not to make it too easy, but to make it a bit more fun when we create these 2 classes revolving around superheroes. We need an easy way to kick things off with class inheritance, and I believe that this is it. This code is all about superheroes and their incredible abilities. We're going to dive in to this exciting world and explain this in simpler terms. I'm hoping you've already had a read through this challenge description. Let's head over into our code. Okay, here we are in our code. Now, I need to create a superclass before I create my children classes. And in this challenge, we're going to have one superclass and one child class. We know that our superclass is going to be called superhero. We know that the first method in a class is init. What does the superclass init need? What does every superhero have in common? Well, they're going to have a name and a power. What can they do? For each of these, we can create our property, our variable for this class, self.name equals name, self.power equals power. In the superclass, we're going to have a few methods. Now, the first method can be like use power, right? And this is just going to display a little information about our player. This can say something like, player's name is using something power, right? And inside here, we can put our name. And we will put here our power to use them both. All right, so now anytime we call that method, it'll use the player's name and the power that they have. Okay, great. We could call one called, all right, we could make one called intro hero, or just intro, honestly. And this one could kind of do like the same thing. Something like that for our hero. Okay, cool. Let's make 2 more. Right? So just getting in the habit of using our properties, using f strings, creating methods here. Right? All these methods are very straightforward and to the point. So print, what do you want to print here? I could just say self.name has saved the day. All right, what do each of these methods do? Well, all they're doing is printing something. I'm using the properties that we defined inside our constructor in different methods around my class. Let's create a final one, and let's call this like power level. Now, in here, what we can do is I want to know how much power they have. And specifically, like, what is their power? For example, if I come out here and I say fly, or I say strength, I want to know how powerful they are, or specifically how long they are. So fly is 3, strength is 8. That's the length of the word. So I kind of want to figure that out here because power level. Self.power is going to be a word. So in here, I could just say length, and we could get the length of our power word, right? And then the level of power we have, we could just say, okay, whatever their power length is, that's going to be their level. But then you can multiply it by something like 10. Then we can give back our level. We can return our level. So our superclass is done. For the purpose, let's kind of create one. Let's say Batman. Before we create a child class, let's create our object just using the superclass. Okay, so let's say Batman. Honestly, Batman does not have a power, but I am going to put flight just because his name is Batman. Very nice. Let's run this code. Now, nothing's going to happen. I should be error-free. Great, I'm error-free. Now, after this, I could take my object, Batman, and let's call like intro hero, and let's call one more, and let's say Batman.power level. There we go. Now let's run these, and this I'm going to print off because I'm returning. I won't be able to see anything. There we go. I am Batman, and I have the power flight, and the power is going to be 60. All right, because flight is 6 letters, 6 times 10 is 60. Our superclass is working, okay? Now, I'd like to be more specific, and I want to create that child class. So let's create a subclass, and let's call this flying. So this child class will be given to all the superheroes that can fly. And they are still superheroes, so they can inherit the original superhero class. Inside here, I need to create one new property. What do we need to do if we create new properties for a child class? Well, new properties mean init. We need to have init. Inside init, I'm going to put the first 2 parameters of my initial superclass, name and power. So name, power. Then I can create any new properties I may have. So let's just say speed, like flying speed. How fast can they fly? Before I create a property for speed, I need to activate my superclass. We can do this by using the super function linked to the init method, just like so. Inside init, what do I want to initialize? Well, I want to initialize my 2 parameters, name and power. Then feel free, you can create any new properties that this class is going to hold. Nice. Our class superhero constructor is completed and ready to be built out. Reading through the challenge, what 2 methods do we need here? Well, I would like to have a method called usePower. UsePower, the only thing this is going to do is I'm going to combine a few things here. I am going to print off, and we can print off our name. Right, so I'm going to say like Batman is flying at the speed of, that's cool. Then I'll put my speed miles per hour. There we go. So in here I can use my self.name, and I'm going to use self.speed. Now remember that this property is being inherited and initialized through my superclass. Because we're inheriting it and we're using the word self, that is unlocking everything in our superclass. Pretty cool. That is the purpose of class inheritance. Okay, our last method, I'm going to say like calc distance. Right, because I want to calculate the distance the superhero can fly. And I'm going to give it a flight time. How long were they flying for? And the distance is going to be a local variable. A variable that's only created and used inside this method. And the value is going to be our speed, right? And I'm going to multiply that by our flight time. I can then return my distance variable. Alrighty, our classes are fully built. That's it. I'm going to head down here to our objects. Now, I'm going to create 2 objects here. I'm going to keep Batman, actually. And I am going to create another one called Superman. Superman is going to be an object of the flying class. That is my child class. Now here, I need to give it a name. He will have flight. And then because He's from the child class. I need to give him 3 arguments. Batman is from the superhero class, which only requires 2 arguments. So for Superman, I can say, what is our last one? Speed. I will say 250 for speed. Let's change Batman's to strength, like so. Great. On the second object, all right, I am going to, let's call Superman. I am going to use this method with Superman. So I can use intro hero again. Nice. I can use Superman. Let's use power. That's coming from our child class right here. Then let's call, I'm going to call attack. I'm going to create a variable. And this can be Superman dot calc distance. All right, then just down here at the bottom, let's just print out some information. So I kind of want to say like, my superhero can fly a distance of. They can fly a distance of whatever this method returns. So I can use attack, because that will be the value. So superhero can fly a distance of however long miles in, what is their flight distance? Flight distance, hours. For name, I could say Superman, right? But I actually want to target the properties. So remember we worked with this. Why not say Superman.name? Superman.name. Okay. Let's give this a whirl. We're going to see a whole bunch of things happening here. Okay, nice. I could even put a print here so we can even read this more clearly. The Batman one runs like normal, and then we have our Superman. I am Clark Kent. I have the power flight. Right? That's happening right there. Use power, it says Clark Kent is flying at a speed of 200 miles per hour. Okay? And then our last one is Clark Kent can fly a distance of 7,500 miles in 30 hours. Wow. Very nice, guys. That was our first real introduction to class inheritance. We have a superclass called Superhero. This is being given to our child class, flying. The child class inherits everything from the superclass and also has one new property of its own. I made 2 objects. Our Batman object is taking the class Superhero, the superclass, and Superman is using the child class, flying. Very nicely done. Let's head over into our next challenge. I will see you guys there. Here we are in our second challenge. I hope the first one really kicked things off for you guys and sparked some interest and understanding of class inheritance. This is our second challenge. In this one, our code we are making is going to be a library management system. This system is going to allow you to manage a collection of books, and our system is going to provide functionalities for adding books, displaying all books, searching for books by author, and searching for books within a specific year range. Wow. So we are actually creating here a library management system. We are going to use superclasses, and we will have children classes as well. Don't stress out. Although we are going to have many different classes, a lot of what we're going to be doing is using our properties to output strings with print. But this is really going to build on the purpose of showing you that you can work with multiple classes. All right, let's jump into our library management system. I'll head over to our code. In our code, to kick things off, we need our superclass. We are in a library. What should this be called? Book. Logic. Okay, our first method, always our constructor. What information do we need to know about a book? Title, author, 2 good things, and year. When did they publish the book? For each of those, just go through. Remember, every parameter that we give in it needs to have some type of property we can use throughout our program. So I'm creating one. Self.year equals year. Nice, that's it. Now the only thing the superclass is going to do is display information about a book. How can we do that? Well, let's just create and let's just say book info. Remember, all your properties and functions and methods, you should be using really specific names to help you understand, but help other developers understand too. So book info, awesome. What do we want to print out here? Well, I'm going to print off a title. I am going to print off an author. And I'm going to print off a year. Oops, I should have done an F string there. You can say year. So in here, self.year. There we go. In here, self.author. And our final one will be our title property. Cool, that's it. Okay, so this is completed. And to kick things right off, I will create an object called Harry Potter that we can use to change as we create. I will call this Harry Potter. I haven't read a Harry Potter book in a really long time. J.K. Rowling, I know that. And then I don't recall when the books came out, like The Sorcerer's Stone. I'm going to put 2005. That's probably not right. Let's take our new object, Harry Potter, and I'm just going to link the book info method. Right? What do you expect to be output? These 3 lines. To run a quick test, let's just make sure the initial superclass is working, and we can see there in our terminal that it is, and it looks great. All right. So our object is completed. It's always a good idea to keep our classes together. That's why I put all this space right here. Now, what 2 types of books do we have? We have nonfiction and fiction books. For each of these, let's create a child class. So I can create a class called fiction book. I know this is a child, so it will inherit our superclass. Now, this child class, I would like it to have a genre. So if I want to create a genre, what do we need in it? Okay. Before I continue, just remember those 2 takeaway points. Most of these challenges, I'm trying to get you comfortable with new key terms and new aspects like the super function and things like that. If you do not have a new property, do not make the constructor function in your child class. You could just start making new methods once you inherit, just like from our lesson. All right, this init is going to take a few things. I can just go up here and I'm going to copy these 3 parameters, use them here, and then our last one, I can create a genre. To activate all of those, we can say super init and then put those inside there. Don't forget to make a new property for the final parameter. Nice, alrighty. So fiction book. I'm going to create a method to, let's say, show info about this book. Now, I want to basically pick up where I left off. So when I call this show info method, I want this to basically automatically run, Then I also want to say like genre, and I'm going to have my self.genre. But that seems a bit counterintuitive. That's just repeating a lot. These were already taken from our superclass. So let's use the book info method. And let's say, well, let's keep the same names. So I can say book info. Now, the problem becomes which one is going to work? Well, if I create an object from my child class, it's going to use the child method. When it hits and runs the child method, the first thing I want it to do is I want it to call the book info method from my superclass. Then it can print off my genre. So let's give that a run so we can see what's happening here. I'm going to change my class to fiction book. Genre, I don't know, is Harry Potter adventure? Adventure. Okay, you can see here I am now calling book info, which is actually this method now because I am using my child class. Run our code. There we are. So instead of just printing all over again, I just activated my book info method that came from the super class. Okay, now going forward, I changed both of these to book info, right? And I did that because I'm going to be working with many classes here. But if I only had these two classes, we don't need super. If we had our own name in the superclass, so info, I don't really need to say super.info because it has its own unique name. To use it, I could use it just like a property. And I could say self.info. That corresponds to our info method from the superclass. And I'm inheriting it because we're inheriting our superclass. This would do the same thing, right? So if I only have two classes, this is perfectly fine. Because I have more than two I'm about to make, I'm going to keep with using super. And I will keep with the naming convention of info for now. All right, our next class. The opposite of fiction is nonfiction. So let's say nonfiction book, but it's still a book. So it still inherits our superclass. And our init is still going to take those properties. Now, a nonfiction book is going to have a topic. What's the book about? So that's pretty much the same thing as genre, but let's use topic. We will do our super init, right? Get all those working again, get our parameters in there, and then create a property for our new parameter topic. Okay, pretty cool. Now, I want to do the same thing. I'm going to copy this method. I'm going to take it. I'm going to put it in here. They are all called info. The order, the precedence that they take is the object that you make. So when I create my objects, I'm going to create 3 objects. One object from each class so we can really see what's happening. Whatever object is using that class, that is what's going to take precedence. Now instead of genre, I'm going to change this to topic. And instead of our property, topic. Great. I hope we see what's happening. I hope the gears are turning. Alrighty, going down. So everything is pretty much completed, okay? We do need our last class, but let's get some things running first. So Harry Potter, I don't know a good nonfiction book, so National Geographic, that can be non-fiction book. Okay, Nat Geo, let's do our info. I don't have book info anymore, right? I've changed that. And then let's create one more as like the main book. So to show us that I can create from the superclass. So main is just our superclass, book. So I can say test. Author, I will say me. And year, let's say 2023. Then I will call main.info, which is the info method in the superclass. So you see, they are all using the info method, but remember, their info methods are all slightly different. Okay, for the purpose of readability, let's put some prints here. Okay, let's run. Brilliant. There we go. Let's make this even bigger. This is from our superclass. Test, Josh, year. Our fiction book has the 3 of the same properties, and then we have a genre. And then our nonfiction book has the same 3 properties, but it has a topic. Right? Very, very cool. All right, let's close this. I'm now going to make my last class, which will be the most useful one, actually. What we've done so far is kind of like create a database of what type of book is it and what genre it has. But now I need to create a library to store everything, not just the general descriptions. So let's create a class library. This will not inherit anything, which is a good thing for us. This library class is going to do a few different things and all the interesting stuff. So I will create an init here, but init is not actually going to really do anything. It is going to serve as a home for all of our books. So let's create a list where all of our books will be held. We can create a method to add a book. I should say one book. We're not adding 2 at a time. So self, and then I'm going to give it 1 book. I want to append this book to my list books. Right, just like so. It's going to go in there. Okay, nice. Let's display books. I want to show all the books that are in my list, pretty much. So how could we display all the books? Think about that. I have a list, I want to go through it, and I want to print all the titles of the books. How can we do that? A for loop. For every book in my list books. Cool. I can take book. Any guesses what we want to do here? Info. I want to call the info method because I am using the word self. After I print off the info of every book, I am going to put a space. We will see this in action in a little bit. But if I have 10 books, each book has a name, an author, and a year, I want to see that 10 times. So all the information about the books. All right. We are able to search by author, which is pretty cool. So I want the ability that you have a favorite author. You can look for that author in the library. That sounds useful. So in order to do this, what I'm going to do is I want to loop through all the books we have. And every book I go through, if it has the author I'm looking for, I want to take that book and I want to add it to a special list just for that author. Once I've gone through the entire library, I can print off that new list of the books that were written by the author I'm searching for. So, the first thing we can do in this new method is let's just say found books. This is like a local list that any book that I'm looking for written by that author is going to be added for. For every book in our list books, if the current book author is equal to our parameter, the author I'm looking for, object property. I'm accessing my object's property every time our loop runs. It's checking for the author, and it's checking to make sure the value of this property is what we entered into our parameter, or what we gave to our method. So if that's the case, I'm going to take my new list and I want to append that current book I'm on. Great. Once the loop's done, if the new list contains data, so if that's true, if there's books inside that list, great. I want to print off, and I can kind of print off some info about this author. So I can say like books by, and then let's get our author name in here. Well, I can't really say self.author, right? Because this is a class that's not inheriting anything. So I can say author. That's the info we give here. For every book in my new list, found books, what do we want to do here? Well, book, I want to info. I want to call my info method on that book, just like we did in the previous one. Great. I might as well throw an else in here, just to alert the user that no books found by this author. You should be really seeing what's happening. We are building on, gradually, the foundations of Python, which you should have entered this course with, and we are building on object-oriented programming. So taking those fundamentals and the foundations you already have and turning that into object-oriented programming. Nice. Alrighty, very nice. That brings us to our final method. I did say that we wanted the ability to search by year, right? So I want the ability for that. So I'm going to give it a self, right, in a year. But, let's also say start year and an end year, right? That's what we should be doing there. Okay, so once again, I pretty much want to do the same general idea as the search author. I want a child list, okay? And this child list, so for every book in our list books, okay, great. If my start year, so that's my parameter, if my start year is, we can say less than or equal to the current book's year. And that book year is less than or equal to what? Our end year. Okay, so I'm accessing the current book's year. And I'm saying if the book's year is greater than this number and less than this number, I want to do something. I'm noticing a problem that I could have. Let's do a few things here. Well, the problem can be fixed on the outside, right? Just be careful. These are using the child class. These do need to be integers when they're passed into this class, as we are doing some logical expressions. So if this is the case, what do we want to do? Just append it to your list, right? So what do you want to append? I want to append that current book. Great. When that's done, if we do have books in the library that have that, then let's print off just some basic information. And you could say like books between, okay? I'm going to say start year. So books between the year 2000 and the year 2010. I can say that. Nice. Then for every book in our new list, found books, what do we want to do? Drum roll, please. Take the book, call the info method on that book to get off our info. I'm just going to say else, print, let's just say error. Okay, errors, it's fine. Wow. Look at everything we did. Take a moment. Pause me. scroll up, look at what you've done. Nice. Very nicely done. All right, so getting back down here to the bottom. Okay, so I actually already have some books I'm going to use as my examples. Okay, so I'll space these out for you. Be creative here. Okay, so I create an object called library. That's being right there. In this library, I have 4 books. I still have Harry Potter. I have The Great Gatsby, 2 fiction books. They are objects from the child class fiction book. I then have 2 non-fiction books, childs from the non-fiction class. Now I can actually go through and I can use all of these. So library is like our main object. And I want to add these books to my library that I can use later. How can I do that? How can I add these 4 books to my library? Well, you have an add book method, and this takes a book or an object. I can append an object to a list just like we did in the last lesson. This object, I now have the ability to access their properties because we added an object to our list. So, library.addBook, book 1. I'm going to go through and we're going to add each book to our list. Okay, so now each book is added, right? It's like a database. Now I can take my library and I can do some pretty useful things here. Let's say library. Let's call display books method. That's going to print all the info about the books. Run it. Wow, look at that. That's cool. Nice. So we have each book's information just like a normal library database system. Very useful. Very nice. Let's call library search author. Who do I want to look for? Let's go up and let's take F. Scott Fitzgerald. Let's search for him. Okay. And then while I'm here, let's say library.search year. Now, it takes a start year and an end year. So where am I at here? Let's specifically look for this book. So I'm going to say the year 2000 until the year 2020. That's 2 decades. Let's turn off display books. There we go. So I searched for F. Scott Fitzgerald. So it says books by F. Scott Fitzgerald. It prints off the books by him. Books between 2000 and 2020. Prints off that book. If you're still here, you stuck with us, amazing. Guys, if you struggled at all with this, that's fine. Slow down, okay? Go back to the previous task. Take the task, and I want you to change elements in it and make it your own. Make it about a hobby you're passionate about or something you enjoy. Break down class inheritance. All these new terms I'm using, properties, methods, parameters, arguments, you should know these now this far into the course. If there's anything you want to review, go back and review. Take a few of the quizzes. You're doing great. I'll see you in the next challenge. Here we are in the final challenge of this lesson for class inheritance. If anything, I've called this one the 4th challenge, but this might be a bonus. This one is going to be quite challenging and use things we haven't learned yet in this course, but through the foundation and fundamentals of Python, you should have already learned and experimented with. We will use dictionaries in this challenge. If you are not confident with dictionaries or you've only learned that briefly, I suggest you go and you spend a few minutes, when I say a few minutes I mean 10 or 20, to refresh on what a dictionary is and how we add and access the values of a dictionary. I'll give you a tip here in a few minutes on how to remember how to access elements from a dictionary. What we want to do here is we are creating a country information system, and it's going to allow users to retrieve information about different countries. Our system is built using class inheritance to categorize countries into two types: developed countries and developing countries. Now, I'm hoping you read my description for this challenge. A dictionary, very briefly right here, I'm going to type it out. I am going to say, let's say we have a dictionary called country. Okay. To access a value, dictionary key is equal to a value. Okay. I'm going to type this out, and I'm going to say how I tell my other students is I say dictionary. Let's use an arrow. So dictionary key unlocks a value. Okay? If you have to say that 20 times, do it. Annoy yourself. Go to sleep thinking about that. Dictionary key unlocks a value. Dictionary key unlocks a value. Anytime you want the value of a dictionary, you need to insert the dictionary key. The key unlocks a door. The same thing for a dictionary. Let's go into our code. All right, so our superclass is going to be country because we have developed and developing countries. So let's make a class called country. Our constructor should have a few details. What do you think this constructor should have? I'm going to say a name, a capital city, and a population. That's a good starting point for a country. Because a country needs all three of those. It needs a name, it needs a capital city, and a country, hopefully needs a population. I'm going to say self.pop, actually. And we still need to use population. Okay, nice. Now, I'm going to get the info about this country. But instead of just printing line by line, I want to create a dictionary that I can use in other parts of my code. Because the ultimate goal is I want to return the object's value in the final lines of code, which you'll see here briefly. So I'm going to return a dictionary. Now, in a dictionary, remember, we have key pairs. So the first is our key. Then the value is what's next. So self.name. Together, these are a key pair. I have my key, I have my value. Every key must have a value. If I delete the key, I automatically delete the value. I have a name, capital. And finally, population. Okay, brilliant. That's all that this is doing. It's returning a dictionary for me that I can add things to and use as I wish. Alrighty, our next class, let's call this developed country. So countries who are already developed, they will inherit the initial foundation of our superclass. And let's create an init. Okay, so self, we can take our 3 parameters from the superclass right there. In this class, because it's a developed country, let's give it a GDP. Okay, so super, I am free to activate everything from that. And we can create a GDP, gross domestic product, for this child class. Nice. Okay. Now, I only want one real method here. So, similar to what we have been doing, guys, I can create my info method, getInfo. I have that in my superclass. But this is going to be slightly different. I need to access my dictionary. But my dictionary is held in my superclass. Any guesses or thoughts on how we can do this? I'll give you bonus points if you actually put in the comments of this lesson what you thought of before I said anything. How do we access this dictionary? Well, let's create a dictionary. I haven't kind of created one yet. So let's say, I don't know, my dictionary is called info. The value of info, let's initialize and let's get our dictionary, getInfo. Okay, so now I have a dictionary to work with. My dictionary is called info. I want to add my gross domestic product to my dictionary. So how do we access that again? Remember, dictionary key value. Say that 3 times. Dictionary key value. So my dictionary is called info. Insert the key. What is my key? Well, it's going to be GDP. What is the value? Self.gdp. Cool. I can now return my new dictionary. Look at what we've done. Compare this with working with dictionaries and other things you know, okay? Nice. This is a data structure we haven't used in this course yet. Dictionaries are our friends. They are like advanced lists. Dictionary key value, or a dictionary key unlocks a value. Very nice. Okay, then let's go down here and let's make a class for developing country. We can still give that our superclass country. We will still create our constructor. Let's give it those 3 following. Then I'm going to give it HDI. There we go. That's for developing countries because they can use that. Init. Cool. Paste in those. Nice. And we're pretty much going to do the same thing here, guys. So I'll create my property for HDI. And then down here, I can also create a method for getting info, which initially is going to be past the same thing. So I'm creating a dictionary from this, right? And then I need to add a new key pair to the dictionary. So I'm going to access my dictionary. The new key is going to be HDI. And the value is going to be our property, HDI. Then we can return this dictionary, info. What do you guys think? All right, our superclass is country. We have 2 children classes. Now we can create a class that is going to use all 3 of these. So let's say class world, right? All the countries around the world. How can we add objects to this class? Well, if you said, hey, Josh, why don't you use a list? Well, you're on the right path. Let's say countries, empty list. Cool. What do you think we need? Let's add a country. All right, we've been working with this. So country, let's add in a country. Let's take our list, countries. Let's append that single country we've just added. Okay, let's give it some more space. Then our final one I've said that we need to create is, let's just say get country info. Keep with that naming convention. So I'm going to be giving it a name. Okay, whoops. For every country in my list countries, if that current country name is equal to the name that I'm searching for, we can return, there we go, return the current country, and I can call the method we made inside getInfo. Right? So whatever country, if I'm searching for a developing country and I say country getInfo, it's going to give me this. If I am searching for a developed country, it would give me this. They are both called getInfo, but remember that this method is linked to the object itself. If the object is a developed country, then this method is linked. If it's a developing country, this method is linked. All right, I have returned the info. Anything else as like a safety net? Let's just return none. Cool. Wow. Objects need to be built now. Our classes are done. So our first object, let's just say world class. I'm going to use that as like the parent, the main object. Now, I've already come up with some numbers, okay, for 3 different countries. So let's just put those in here. Okay, you can read over those. Be creative, guys. Do some research on your home countries, right? So find the information. Use your country as one of the objects, and then find 2 places you would love to travel to. That's always good if you're stuck and you don't know what to put, okay? So I have my 3 countries, US, India, and China, right? And I'm going to use these. So I got my objects. I need to add my objects to my database, pretty much, right? So my database is at world class. That's what's being used. All right, so we can add in our actual objects, right? We are appending those to the class world, so I can deconstruct them in the world class and I can use their properties. Okay, at this stage in our code, it does nothing, right? Because add country, it does nothing. You just have a list. That's all it's doing, right? So, okay, great. Let's go down now. Remember, we're working with dictionaries. So as like a test, let's just start off. And I'm just going to create a variable, but the value is going to be a method. So world.getCountryInfo. Cool. As you can see, getCountryInfo takes a name. So we need to search for something. So let's say here, Vietnam. I can create a condition. I can say if the country is true. Okay, so if it's returning something, right? Because it's either going to return this or return this. So if it's returning something, then let's say like, I don't know, country info. Let's print off the basic information. And I'm going to loop through. Now remember, our data is held in a dictionary. So I want to loop through and I want to print off the key pairs. I want to print off the key and the value to every key pair in my dictionary. How do we do that with a for loop? This is slightly more advanced with our loops, but let's break down the idea. So for every key and value in my country info, it's my dictionary, I want to get their items. So I want to, if I were to translate this, for every key and value in my dictionary, I want to get their items. Okay. I can print, let's print off my dictionary key and my dictionary value. Cool. And then else, I'm just going to put here as like prevention. I'll say country not found. Wow. What do you think is going to happen when I run this program? Okay, let's run it. Country not found. What's going on? I said Vietnam. Oh, I don't have Vietnam as an object, right? I'm hoping you guys caught that. Okay, let's take this. Let's now say India. Country not found. That's also an issue. Why? Why is that? If I capitalize India now, there we go. There we are. Okay, so before I get on this information, I'm going to talk about that. Initially, I said India, right? You are not putting the object, right? So for example, if I put this object, India, let's watch what happens. Country not found. We are not putting an object. You are putting the country name, okay? Because get country info, it takes a name. For every country in my list, if the country name is equal to the name I entered, return country info. Right? So let me go back now. Let's do USA. Country not found. Okay. Well, because the proper name is United States. Okay. Prints off country info. Let me go down here so we can see. It says name United States, right? Name is a key. The value is United States. Capital, Washington. Capital is a key. Washington is the value, right? Do you see how we're unlocking our entire dictionary and using those key pairs? Very well done, you guys. I'm so proud of you for how far we've come. Over the last 3 lessons, you have learned so much about object-oriented programming. You got an intro to working with objects. We learned how to define and create your own classes and objects. And in this lesson, we talked about class inheritance, which has prepared you for our next lesson. Let's head over and let's introduce the next concept in object-oriented programming. I'll see you guys in the next lesson. All right, welcome to our next lesson. In the last lesson, we introduced the idea of class inheritance and how we can create a superclass and give that class to other derived classes or child classes. In this lesson, I'm going to introduce to you the concept of multiple class inheritance. Now, when it comes to this, I want you to think about just normal inheritance, but instead of accepting just one class, we can accept multiple classes. Great. Let's jump in. As our example here has, we have the animal class. And I want you to view the animal class as the base class. Everything is derived. Everything comes from this animal class. And it provides the basic for all the animals. Each animal can then do something special. So we have 2 subclasses. We have can swim and can fly. And then finally, we have a child class. We have a class called bird. And bird is inheriting not 1, but 2 classes. Right? We have our base class. We have our classes that define behavior. Yes, I did not make a land class, right? So animals for land, but you could have that, right? So every animal could have a few things. We have our species, the type of animal. You could have a region of the world this animal is found. Is it dangerous? Things like that, right? And then other special classes for specific animals like a fish, a shark, a dolphin, or can fly, right? You would apply that to a bird. So everything there is being passed down, okay? We do this the same way we inherit a single class, but we do this with 2 classes. So in the example, we can do that by entering two classes in. In those classes, we just need to separate by a comma. Therefore, we can inherit any other classes we want, more than just one. So take a look at this code. This is a very basic setup of multiple class inheritance, but it still does a good job at expressing what's really happening behind the scenes. We have a class for our animal. This is the base class. This class also holds our constructor method in it, with only one property. We also have one method, eat, and this just prints off the name of the animal is eating. Great. The animal class is complete. I then have a subclass, and this class is called canFly, and this will be applied to any object that is an animal and can also fly, so my bird. Finally, we set up our child class. This is the class that's inheriting our two other, let's call those parent classes. We create a constructor and we initialize the name from the superclass animal. I then justified one additional property for color, for the color of the bird, right? And then I have one method here. And this is going to print off the color bird is sleeping. So the red bird is sleeping, right? The blue bird is sleeping. At the very bottom then, I'm creating an object from my bird class. Then I'm linking my object, my bird, to the three different methods we built. Each method is a part of a different class, but we are inheriting all of our classes in one. Okay, let's space out our alignment. Here's the setup for that in order, broken down, right? Python reading top to bottom. It's good that you have a good structure for your code. Now, if you haven't quite caught it, I'm going to get an error. Why is my program going to run an error? Think about it, pause it, try and find the error. Great. Because initially I did not have the color, but because my object is from the bird class, I have name and color. What color is the bird? When I create my object, I'm giving the name or the species, and then I'm giving the color, therefore calling all three methods. Because we're using the super function here in the child class, we can pass the name to the parent class and to the other classes which need it the most, right? They're all kind of hopping around. And by using that super function, we can therefore take what we want to initialize and pass that around to the other classes that we are inheriting, or our super classes, right? I have my super function. And because I'm inheriting these two super classes, I can initialize the name to use in my two super classes. Great. Let's take a look at the first challenge that I want to kick things off with. Here we are. So don't go back. Okay, don't go back. You can try this one on your own before you jump into VS Code and you watch a few of the challenges that I have prepared. This may or may not be one of the challenges that you'll see a video of. I want you to try to recreate the code from the previous slide. Use it as an example to build your own. I chose the topic animal with can fly and can walk, but you should be choosing a topic that interests you. Where do your passions lie? Create one base class, which is my animal superclass, and then two behavior or style classes, which mine were can fly and can walk. Finally, create a final class for one child class, and you just need to use print to interact with all the classes. Nothing too complicated, just to showcase your understanding of multiple class inheritance. Remember to use the super function to pass the arguments around to our different classes.
I'll see you guys over in VS Code for our first challenge. Here we are in the first challenge. I'm excited for this one, guys. Let's go through and check out the description quickly, which I hope you're all brushed up with, and dive right in. So, in the world of transportation, we are evolving. We have smart cars, we have electric cars, hybrids, we still have gasoline. It's changing. We have a superclass called vehicle, and this represents the generic vehicle with all the generic attributes. Make, model, year. But we also have two specialized classes, and this is going to be your electric vehicle and your gasoline vehicle. The electric vehicle is going to focus on any vehicle that's powered by battery, and it's going to include properties or features like battery capacity and the ability to charge. Our gasoline vehicle class is going to deal with vehicles that are obviously powered by gasoline, and this will have its own properties like fuel capacity and ability to refuel. Both of these classes have a method called getRange, which is going to help us calculate the range of a vehicle based on their respective energy sources. Our job is to make a derived class, a child, called hybrid. Hybrid is going to inherit everything. Let's jump in. Heading over to our code. All right, to kick things off, let's make our base class, right? Everything is going to have vehicle. So I'll say vehicle. I will define my constructor in it with our key self. We then have a make, a model, and a year. For each of those, you can define your properties. Then, I am not going to do anything else for this class. This class is like a mini database. If I have 10 different car objects, each object is going to have these 3. I can hold in one object 3 values. That's all this is going to do. So think of this class like a mini database for each object. Awesome. Continuing on, let's make our class for electric car. Okay? This will actually not inherit anything either. So I can create a constructor. And for this, I'm creating its own properties. So remember, let's just create battery capacity. That's a good one. And I'm going to say create one. So let's say let's say battery cap is equal to battery capacity. Great. Then I will create a method for charging. All of our electric cars can charge. Self. Inside, we can just return the battery capacity. That's all we want to do for that. Finally, what is an important thing to know for an electric car? Well, our range. Now, I cannot say range because range is already a special Python function. So let's call this getRange. That's its own unique name, right? That's a much better name. Our range, we can just return let's say our battery capacity, and let's say the range on the battery capacity is multiplied by 5. Looking great. Alrighty, and our last, let's call superclass or parent class, is the last type of car we have. And I'm just going to say gas car. The gas car has its own constructor, and then its own property is going to be fuel capacity. And we can make one called fuel cap, and that's going to be equal to our fuel capacity parameter. Inside here, we can call one and say refuel or get gas, right? And all we're going to do is pretty much the same thing we did for the electric car one. So we can say self.battery
battery, well, not battery, in this example, it'll be fuel cap. And then we will have self.get range. And for this range, we can return something like, let's say you got 20 miles to the gallon, right? So if you got 20 miles to the gallon, we can multiply that by 20. Great. So we have 3 parent classes or superclasses here. Now I want to drop these in to a child class, a derived class. And this derived class is now a very specific example of a type of car we see out on the road. Let's make a final class called hybrid. It's a hybrid car, so hybrid. Hybrid is going to inherit actually everything, right? It's going to get the info from the vehicle class. It's going to get the electric car info, because a hybrid's half electric and half gas. So look what's happening. We can take any other class and we can pass those in. I'm giving 3 classes to a derived class. Now our hybrid, we are going to do a lot here. Well, not actually a whole lot, because it's really just init doing all the work for us. What do I need to put inside init? Well, I need to put all the parameters we initially made. So all the parameters from vehicle, I'm going to go and I'm going to put the parameter from electric car, because we're going to need that. And then we are going to put in the parameter from gas car, which was fuel capacity. What do you think I need to do now inside init? I don't have any new properties. I'm inheriting them all. I need to activate them, each of them. So I'm going to say super.init. Don't forget your underscores. So for this init, I'm going to take these first 3 because that's coming from my first superclass. Great. Let's just copy that row. We need 2 more. So I can have my next row for super init. And inside here, we just need to activate our battery capacity from the electric car superclass. Our final one, we just need to activate our fuel capacity. All right, so now everything is stored locally in this hybrid class, which I can call all 3 of my other classes to use methods and get information. This is great. Let's finish out this challenge. What I'm going to do here is I'm going to create an object. Let's just call this car. And my car is going to be a hybrid type of car. What arguments do we need to give here? Well, we need to give it a lot, actually. So I'm going to start things off with a make of car, because I have here make, model, year, in order. So my make, let's say a Toyota. I think you know the model of car I'm going to do. I'm going to do a Prius. Let's say a year. Year, let's do 2023. For battery capacity, let's just give it a round number. Let's say battery capacity is 5. And then finally, fuel capacity, let's say it can hold 40. Great. On my car object, I want to call a few things. But notice, right, we are returning. When we're returning from a function or a method, the value is going to be used as the value to a variable. So instead of taking my object right now, I'm going to create a variable. And let's say I want to know my battery capacity. What is the value to this variable going to be? Well, the value to the variable is going to be whatever this returns. If this returns 20, okay, then this should be 20. To get that, I need to call my method. So I'm going to take car, and I am going to call charge. Just to run through very quickly, if I print off my variable battery capacity, it should print off 5. All right, so, okay, I'm actually given an error. Let's go through and address this quickly. So, missing 2 required, all right. Inside of our init, let's just go in, because I'm using 3 of these. It's bouncing around. Let's just go inside here and let's say self for each of these. Okay, I'm using 3 supers. Let's just put in self. Trash my terminal. Let's try it again. I should see the number 5, and in matter of fact, we do not see 5. Okay, let's take these. Let's not use super 3 times in a row. Let's link our actual class. So in the first one, vehicle. In our second one, electric car. And our final one, let's say gas car. Great. So I've linked the classes within it. There we are. I'm given back my number 5, right? Because battery capacity is holding the value of whatever this method returns. That's 5. Looking good. Good tests. Now, going forward, let's just print off basic information about our car, such as battery capacity, battery range, fuel range. Okay, so we have battery capacity, I have my fuel capacity, and we have our battery. I have 2 batteries, those, no battery range. When we run our code, we are going to see a few outputs here. There we go. Battery capacity of 5 kilowatts per hour, fuel capacity of 40 gallons. We have our battery range of 25 miles and our fuel range of also 25 miles. Looking great, except these last 2. They're both saying 25 miles. I'm going to throw a really easy fix in there. Let's just honestly say get fuel range for this one. Split things up a little bit. So let's say fuel range. Run it again as our final test, and we should see, there we go, looking much better. Great. I hope this was a very easy way to introduce to you guys the basics and the concepts of multiple class inheritance. Look back through these videos, especially in this video, and before going into the next one, leave a few comments and a few notes in your code. Use VS Code as a big notebook. I'll see you guys in our next challenge. Great. Let's kick off our next challenge. There is a bank that offers multiple types of accounts to its customers, just like any bank. We have a type called savings account. And our savings account is a special type of account that allows customers to save their money and earn interest. Although it's not that high, we still get interest. This is what we want to build out. We're also going to have a few other classes, like our main account class, our interest account, and then all of our transaction history needs to be held somewhere too. This challenge is going to be a bit harder than our other ones, and we are going to be doing some mathematical operations as well. Think banking, and think how this can provide a real value to a customer. This is a real-world scenario problem. Jumping over into our code, let's kick things off and let's make our account superclass. This is strictly going to hold our account number, our account balance, and then any deposits or withdrawals we make to this account will also be applied here as well. So all the basics. Our constructor method is going to take our account number and our balance. So let's say account num and let's say our balance, like so. Every user needs to have their account, and every user is going to have a balance with that bank as well, so balance. We need a method for all our deposits. Now this doesn't actually have to do a whole lot. Every time this method is called, all that we want to do is we want to take our current balance and we want to add an amount to this. So this amount can be declared as a parameter. when we call this method, we want to give this method an integer or a float to be added to the existing account balance. Nice. Pause the video, try to make the withdraw method yourself. What could go wrong in this method? Pause the video here. All right. Our withdrawal method, let's say withdrawal. Withdrawal is also going to need an amount. How much do you want to take from the account? Before we withdraw, we need to make sure that the balance, we need to make sure we have enough in the account. How can you do that using a conditional statement? If your self.balance is greater than or equal to your amount, you can do that, right? Then you're going to take your current balance and you're going to subtract your amount. What could go wrong? Well, you have no money. So let's print off and let's say not enough funds. Like so. Okay, that's it. Great. The last method I asked for us to make is going to be a getBalance method that is just going to return how much money is in the user's account. So I can just say getBalance, the balance of your account, and all we want to do is return, and we can return getBalance, or I should say return the current balance, like so. Very good. So our main account is done. Right? A user opens an account at the bank, and these are their options with that bank. They can deposit and withdraw or get their balance. That's it. But now, a user wants to go forth and open a savings account. So this is going to be an interest type of account. Let's create a class for this. Let's say interest account. This new type of account is going to inherit the current account, the base account. In this interest account, we are going to have its own properties. So let's initialize very quickly. Let's say self. Let's go up here. I'm going to take account number and balance, pop that in here. And then the methods of its own, we need a rate, right? Their interest rate. Before I create their interest rate, let's activate our super methods. So let's pop those in there. Let's pop in self. And let's create our interest rate property. Oh. There we go. Very nice. What do we want in here? Well, the only real method of this is I would like to create like a calc interest. I want to calculate the interest. So I can return, what do I want to return? Let's say self.balance. I want to take my current balance and I want to multiply it by the interest rate, which is going to be our new property that we just created here. Right? That would calculate our interest rate. How much are we going to receive? Good. Our interest account class is completed. Before we make our actual savings account, we want to create a book, like for a bookkeeper or a mini database in a way. And I need a place that's going to store all my transactions for me. And this will allow us to store them in a list. So let's create a class called transactions. This is not going to inherit anything. Actually, this is a new class that I can append things to. So let's say init. And init doesn't need any parameters. We are just going to create a property for a list, okay, that I can append things to and remove if you wanted to as well. Everything we do, so if I deposit, I withdraw, technically that's a transaction. So I would like to add something to my list. Let's say that, and let's say transaction. Cool. Let's call our list, and let's append. What do you want to append? I want to append the singular transaction. Brilliant. Finally, let's get our transaction history. So let's just say history. And for this, I'm going to say for every transaction in my list transactions, I would like to print off the transaction. Like so. Looking great. Okay, so look back through what's happening so far. I'm about to jump in and I'm about to make the final class, our savings account, because that's what we're trying to build. Right now we're building a whole system. I built the account, we built the interest rate account, and then we have like a notebook or a checkbook. It prints off all of our transactions and keeps those in check. Great. Our final class. Let's create us a savings account. I am going to inherit. Now here, I actually only need to inherit the interest account and our transactions. But why? Why is that going to give me access to everything I need in my account? That doesn't make sense. Because interest rate is actually inheriting account for us. So I don't need to pass in 3 classes like I did in the last challenge. Because I'm giving interest account, the account superclass, this is like storing 2 classes in one. So I'm only needing to give my savings account class 2 classes instead of 3. Great. In savings account, let's create our init. And we sort of need a lot of things here. We need an account number, you need your balance, and you need your interest rate, right? Which is what we defined everywhere else. So let's pop those in here. Then I am going to call my 2 classes. So interest account dot init. All right, this is like our super dot init. What am I initializing from interest account? Well, I'm actually initializing account number and balance and interest rate in reality, right? Everything. Then finally, I want to use my transactions class. And I don't need to put inside init. I don't need to put anything because we don't have anything inside the init of our transactions class. So the only thing we can put in here is self, right? Our key that unlocks everything. All of our classes are completed. We can now begin to work with our objects. So going down here, let's go forth and let's create an object called savings. And this is going to be our savings account. What do we need here? Well, I need an account number. So be creative, right? If it's a savings account, I could do savings account ... one. I'm the first savings account at that bank, right? Bank balance. Let's say I have 5,000 in the account and I am earning an interest rate of 0.08%. All right? I can take my savings object and I could deposit and withdraw from this, right? So let's hold off on the deposits and withdrawals until we kind of see everything else is what's happening, right? Let's get and let's go forth. Let's say print transactions. Well, I can't print transactions yet. I have get balance, so let's return the balance currently. I'm going to come down here. Let's say savings dot, nope. Let's just create a variable called balance. And let's take our object now and let's say get balance. Remember, I'm returning a value which can be used as the value to my variable balance. So I'm going to say balance and then let's say here our balance variable. That's it. Okay, to fix this error, let's just go up super.init, but 3 were given. Let's try 2 things really quickly. The first one, let's change super here. Let's say account. Let's see if that does our trick for us. It does, right? So now it's printing off the balance of 5,000, and that's what I wanted to happen, right? Great. Okay, we have our variable, the value is 5,000. Okay, now I can do a few new things. Let's do savings, and let's call the deposit method. Let's say, cool, I'm going to give $2,500. So at this point, right, I should have $7,500. But I am also going to make a withdrawal, and I'm going to say I owe rent. So I'm going to withdraw $650. Okay? Great, I've done my withdrawals. So let's calculate our new balance. Great, new balance. This is how much I have left. Alrighty, let's continue on. So now going forth, let's create one called interest. That's going to be a variable, and I actually already have a balance. So this is going to work out good. So interest, I want to get a returned value. So let's say savings, and let's say our calc interest method, right? Now that I have those, we can add in our transactions. So let's add 2 transactions. What transactions do we have? Well, we did this one and we did this one. So currently for adding transactions, you could add the numbers. For this, I'm just going to keep it neat, and let's just make a string. Let's say deposit, let's just say 500, okay? And let's say withdraw, let's say withdraw. And let's not even do that. Let's say, how much did I put in? I deposited $2,500 into the initial balance, and I withdrew $650 from that balance. I have my balance, and then let's get off and let's print off our interest. And then we can get our variable, interest, like so. Looking great. I am going to run our program. Look at that. There we have our balance, right? We then have our interest of $548. Now, the one thing I'm noticing, I didn't display my transactions here, right? I should print those off. So let's say saving. Let's say, ooh, what do we call that? I call that history. So I'm going to call the history method. All right, let's get that bank info. I approve of that. Looking good. We have a deposit of this much, withdrawal of this much. I have my current balance now, and I have the interest that I'm earning on the account. Looking great. I hope the gears are turning, guys. Remember, before you watch these videos, these live code videos, pause the videos. Try these problems on your own. Try and find those solutions, because I've given you the text files, which breaks a lot of it down. So work through a part of it, watch the video on maybe how I did it, pause me again, and then work through the next video. That's how we challenge ourselves and get better. Remember, errors are your friends. Use them to your advantage to help you solve a problem. I'll see you guys in our next video. Great, here we are in our next challenge with multiple class inheritance. In this one, we are trying to create a customer loyalty system. I want you guys to think back on how we did the last challenge and use the knowledge gained from that in order to implement the correct logic and code to solve this one. We are going to create a loyalty system which allows the tracking and managing of loyalty points earned by customers. So start to think about hotels or like airline points. Every time you fly, you earn points to rank up your status within an airline or an organization. We will use class inheritance to organize customers and store their transaction history. Great. I'm hoping you guys have taken the time to read through what we need to do here. Let's head over and let's implement our logic and start coding. Alrighty, to kick things off, we want to create a single object. So I'm going to create a single class to hold the information for our customer. So let's create a constructor, and the only real information is we are going to take a customer ID, so like so, and then a customer name. Every name is linked to an ID. So let's create our properties for these. And this is the only information our customer needs, at least for the time being. So when I create a customer object, the value will be this class customer. And that single object is going to hold our ID and our name. Nice. Let's proceed and let's make a class called loyalty points. This class will be responsible for earning points, redeeming points, and checking our balance. Our constructor is not going to require the properties we made in the customer class, and it's not going to require any information given to it. But we do need one property with the initial value of 0, self.points. We can create a method which will allow us to earn points, and earn points will take the number of points. So I'll say amount. How many have we earned? And all we can do is take our property points and we're going to add in our amount. Great. What if you want to spend those points? You found a great deal on a flight. Well, you should be able to redeem those points. How many do you want to redeem? That is our amount. Now, we first need to check if you even have enough points. So if the points you have are greater than or equal to the amount you're requesting to take out, then you are permitted to do so, and we can subtract the amount requested in our redeem method. Else, let's just say here, yeah, you don't have enough points. So I'm going to say not enough points, like so. Great. And then our final one, that responsibility is to basically show point balance. And all we can do here is we can return self.points. Alrighty, our two classes are done, right? We have one specifically for our customer. We have one specifically for our points. That's going to handle the earning of points and the redeeming of points. Let's create a new class that's going to inherit both of these. Who could that be? Well, a special customer, a VIP customer. What if we make a class called VIP customer, and this will get our customer, and it will also get our loyalty points. Inside here, not a whole lot's happening, but I want to be able to create one object that inherits the functionality of the two superclasses, customer and loyalty points. So I won't make any new methods here. Think of this as a mini database. I will create init though, and init is just going to initialize our customer class and our loyalty points class. So all we need to do here is I'm going to take our parameters from the init of customer, paste those in like so, and then let's just initialize both of our classes. So customer.init, say self, paste in those, take out that extra comma. Okay, so I've initialized that one. And then I'm going to come down here and I'm going to initialize our loyalty points class and just give it self. Alrighty, VIP is done. We have three classes. All of these correspond and work together, and they are held in one class created right here. Now moving on, we will need two more classes actually. Right, this is a great example of OOP. Let's create our two classes for our transactions. My first class is going to be called transaction, It's not doing a whole lot. It'll be like a database, just like our customer class, to store relevant information about each transaction. So making my constructor, the job of this is to hold three things: a transaction ID number, a customer, and an amount. So these will be given to an object, three values, and they will be stored inside one object instead of three objects. Great, now that I have that class done, I can use this within another class. So each transaction will be one object. Each object will hold three parameters or three values: a transaction ID number, a customer ID, or a customer name, I should say, in the amount. Now, I have the ability to create a class called transaction history. Inside here, we want a place to store all of our transactions. So I can create a list called transactions. We will create a method which will allow us to add our transactions. So it's going to take a single transaction. We can take our list. And we want to append that singular transaction, like so. Let's fix this. That shouldn't be a semicolon, that should be a colon. Brilliant. In our last one, I basically just want to show all the transactions. It's a way to check our account. So let's say show transactions. And I want to loop through the list that we created here. So for every transaction in my list transactions, I would like to print. What do I want to display about each transaction? Well, I want those, ideally. So I'm going to say transaction. Let's link our transaction ID for now. Let's link our customer. Well, let's link our current transaction, customer name. And then finally, we can link our transaction amount. Great. Let's create our objects and let's watch what's really happening here. All right. We have just made 5 classes. This is the most we've made yet. These two are working together within our VIP customer. And then we have 2 different classes here. One is responsible for our transaction information. Then one is responsible for our transaction history. Go back through the code and see what's happening there. Alrighty. Our objects. Let's just make one object. And let's say I have a VIP customer. And he or she is an object from our class VIP customer. I need to give them a customer ID. So be creative, VIP 001. All right, and then a name. Let's say I am the VIP customer. Great. My account, let's add a few points to it. So VIP earn points. How many do I want to earn? Let's say I've just signed up for a new airline credit card where they have an award bonus of 40,000 miles within the first 3 months. And then I would like to spend 12,500 points on a quick flight. So that's what's happening there. All right, now for each of these, I should have a transaction, right? So let's make one called transaction 1. And the value of this can be our class transaction. I have 2 transactions, which we see above. So let's make 2 objects. The first argument will be the transaction name or ID number. So let's say T001. It's the first transaction on my account. What do we need here? I need who. Well, who is my object, VIP. And finally, the amount. Well, the first amount we said 40,000. So I'm going to put that there. In our second transaction, we have our same object, and then this time I spent 12,500. And just because I'm reading this out, let's make this a string so then I could actually say plus. Just for the purpose of our list and seeing and viewing the transaction history here. Great. Alrighty, so we have 3 objects on the screen and we are calling 2 methods. It's looking nice, it's coming together nice. Now that we have those, let's make one called transaction history. This is going to be an object from our transaction history class. Now we don't need to give it any arguments here, but we can use those methods. So let's say add transactions. What do you want to add? Well, I want to add transaction 1. I also want to add transaction 2. Remember, these are being added to our list up in this class that we built. Like so. There we are. So we're adding those transactions that we created here. Now that I have transactions added, what could we do? I want to show all the transactions that we've had happen. So take our transaction history, and we are going to link the method show transactions. Great, so it's going to show all of those that are occurring. Now, the last things we need to do is just get our customer ID, our customer name, and the number of points in their account. So because we're returning the number of points in the account, I need to make a variable to store that value. So let's say balance. Now balance is our variable. The value is equal to our get point balance. So show point balance. There we go. Then we just need to print off a few things. So let's print off, I'm going to say here, let's say customer ID. And let's just drop in their customer ID number. Let's print off here, let's say our customer name. Let's say our VIP.name. Looking good. And our final one, let's just say loyalty point balance. And here we can just use our variable balance. This looks great. We took what we learned from last lesson, we implemented key factors here in this challenge, and we even built on it more. Let's run our program. We have our transactions being listed. So transaction 1, Josh, I added 40,000 points, and then we subtracted that. And then you can see I'm getting my ID, my name, and then the balance I have in my account after all those loyalty point transactions. Let's head over into our final challenge for multiple class inheritance. I'll see you there. Here we are in our final challenge for multiple class inheritance. In this one, we are trying to bring in the fundamentals of what you could need to build an e-commerce store, or the logic that's happening in the back end. So we're trying to create an online shopping system, which is going to allow the interaction between customers and sellers. The system is designed using class inheritance to tell the difference between customers and sellers, each with their specific functionalities. Read through this challenge. I've put this as the final one for this lesson, but do we need to use multiple class inheritance or just normal class inheritance? You tell me. I want you to give this one a shot before watching this video. How do you solve this challenge? This challenge is also going to require us to use the open function from Python. We haven't looked at this. Now, this is something you may have to research on your own. Maybe you've seen it before. How do we use the open function? What operators do we use with it? I'm going to break that down as I go through those parts of this challenge. Let's head into our code. To kick things off, up top, we want a class for user. Now, this we are going to create a single object from, and it's going to store a username and the email of the buyer or the person who is signing into the account. Right? If you log on to Amazon, this is you. For each, let's create the properties we can use as we are building this out. We will say self.username and self.email, as those are the parameters. Great. I'm going to mark this class like so. Now we can create a class for customer. Customer will inherit user. We need to access the username and the email. Inside our customer, let's build our constructor. Our constructor, because we are inheriting, will take our username, our email. I will drop down here and let's just initialize it. So with our init, and remember to pass in our username and our email, like so. Oops. I will make one new property here. This property is going to be our shopping cart. So all the items you add to your cart will be appended to a list. Inside customer, we would like to have one that's called add to cart. What will this do? Well, this is going to add a product that you want to the cart. We can append that. We can append that. We have add cart. What if you don't want the item? Then you need to be able to remove that item from the cart. So what item do you want to remove? I want to remove this product. If that product we're searching for is in my shopping cart, then we now have the ability to remove it. So we can say cart, use the remove method. Remove is the opposite of append when working with lists, right? And then anything else we can print off and just say item not in your cart. Let's view our cart. So what do we currently have in that cart? How can we do this? Let's go through and let's just say items in cart. Then we need to go through, so for every product in my shopping cart, we would like to print off the name of that product. So take our product, link the property name. Are we still here? I certainly hope so. This brings us to the last method. Now, I want to have the ability to save my cart as a file. Specifically, a text file. So all text files, they end with our extension txt. So for example, filename.txt. I want to save all this information into a separate file. To do this, we will use the open function. And I need to give it a file name. What we can say is with the open function, I want to open the file name and I want to write new contents inside this file. I'm going to call this file file. So with the open function, I want to open this file and I am now going to refer to this file using the name file. This is like a nickname or a variable we are creating that is linked to this file. For every product in my shopping cart, I want to write in my file. What would you like to write in the file? Well, I can add an F string. And I want to write in the file, I want to write the product name And I would also like to write the product price. Looking great. Once we've appended all of those to a separate text file that's going to be held somewhere else, then we can just print off, and I could say something like cart saved to file name. It's done, right? Once we run this code, we will see the implementation and the output of it. But that is how I could use the open function very basically to work with a text file and append to a text file. The two real new key phrases here, if you've never worked with this before, I'm hoping you did research before watching this challenge, is we have the with operator and we have the open function. With those, we can use the write method to write contents inside our file. All of our customer information is completed. We now want to build the opposite. And we want to build the opposite for the seller. So I can create a class for seller. We don't need a class for the seller's attributes because they can actually inherit user. If you are a seller on Etsy, you're still a user. If you're a buyer on Etsy, you're still a user. Both of those have a username and an email linked to those accounts, which is why I'm using user for both of those. Going forth with our seller class, we will initialize, and inside here we will say username and we will say email again. I can take what we did here, so my super init, I'll take cart, I'm going to change that, but let's take it. I initialized our superclass, and let's change. We do need a list, but the seller is going to have a list of products instead. Not a shopping cart, a list of products. They can do the same thing as we did in the above. So without looking, I'm going to scroll down. Can you do the same methods just in the seller class? So for example, we have add product. We have remove product. Then our last two, we would have view your products, which brings us to our final one. You could have save product. Can you complete those without scrolling up? The same concepts, we're just changing a few small details. Within add product, we need our keyword self, and then we are going to be giving it a list, or specifically individual products to be appended to a list. So self, products, append, product. We can do the same for here. We're going to give it self, we are going to give it one product. Before removing, we need to check if that product is in my list of products. Then I have permission, I can remove that from my list. What do I want to remove? The product that I give as the parameter. Anything else, we can alert the user and say product not found. Great. For our view products, we are going to print off all the products that I have in stock. So list of products. We can then loop through and say for every product in my list of products, I would like to print off specifically the product name. So I'm going to go here, we don't need that string. I'm going to take my product, link the name property. Good. If you're new to the open function, what do we do here? How do I save the products to a text file? Well, we need to give it a file name to be saved somewhere. I am going to say with my open function file name, I want to write the contents inside as a file. For every product in my list products, I would like to take my file and I would like to write contents inside of it. What am I trying to write here? Well, I'm trying to write the product name, and I am trying to write the price of the product. How much am I selling it for? Once we're done with that, you can just print off and you can say products saved to your file name. Where are they going to be saved? Amazing. We are here for our final class. Now I do need to create a class, right? Because a product is an object. And this object is going to store information about the product itself, such as a name and a price, which we've been working with. For each of these, let's create that. So name is equal to name. Your price is equal to the price that you are giving the product. We then have the basic info, so basic info about the product. We are just going to go forth, and I could say print. What do I want to print here? The name of the product. So self name, now that we're in this class. And I would like to also print the price of the product. So self.price. Great. Classes are done. It is time to create our objects, which are going to use these methods that we have now built. On the outside, let's create two people. Let's create a customer, and the customer will be from the customer class. And then let's create a seller. It's a simple transaction between a buyer and a seller on an e-commerce platform. I need a username. So, Billy Bob 123. That's the first username. An email is going to be billy@hulu.com. That sounds like that sounds like Hotmail, right? Our seller is going to be Sarah Jane 88. And her email is going to be jane@yahoo, because who uses Yahoo anymore? All right, so we have our two objects, customer and seller. Now, the seller is going to have a bunch of products, so like product 1, and we could pretty much add all these. So I'm going to copy this, and let's say she has 3 products in her store. The first product can be a pair of shoes. So I'll say shoes. She sells her shoes for $65. Yeah, that's cool, 65 even, okay? Her next product is a ring. And she sells the ring for $125. Something special about it. Then lastly, she sells a t-shirt. This t-shirt can be what? 28 bucks. We have our 3 products which are going to correspond to the seller, and the seller is going to sell them to the customer. Going forth, all we need to do is let's take our customer and let's add those products to the cart. Right? So what do we want to add to the cart? Well, I want to add here, I can say product 1, product 2, and product 3 to our cart. Now they are in our customer's cart using the add to cart method that we made. We can take our customer and let's say view cart. We can view the contents of the cart. So if I were to run this, let's watch what happens. There we go. I have items in cart. I have all 3 of those items that the seller has. So shoes, ring, and t-shirt. Looking good so far. We're error free. I can continue on, and let's now take our customer. And I want to save my cart. I need to give it a file name. So what do I want the file to be called where I save this? So let's just say customer cart, giving it the text extension for the text files. Then we can have, what methods haven't we used? Remove from cart, haven't used that yet. So let's remove an item. Let's say, the ring is too much. We don't want the ring anymore. So here I can take my customer and I can say remove, I should say remove from cart, product 2. I don't want product 2 anymore. Let's now view the customer's updated cart. I'm going to run that. Great. There we go. So cart saved this text extension. I will view that here in a bit. Let's just complete, and let's go with our seller. So I'm going to say seller, add product. What do we want to add? Well, all of those products we've created. So the seller is going to have all three of these. Let's go product 2 and product 3, like so. Very good. Then I'm going to take my seller. I would like to view the products the seller has. And finally, what do I want to do? I want to save the products. Where do I want to save it? Let's say seller products.txt. All right, I'm going to run this. Great, look at that. Items in cart, we have our 3 here. We have our text file extension. This is our updated cart. And then here we have the list of products from the seller. Now, where are the text files? That's the question. They're going to be over here. Let's open our text files. Up top here, we have our text file customer cart text with the contents. We have our seller product text with the contents. If we wanted to get these on one line, all we would have to do, let's go up here to our open function. Let's just put those on a new line, and we can do the same for our other one. Amazing. Well done, guys. That was our final challenge for multiple class inheritance. I will see you guys in the next video. Spend some time to review what we've done here before going into our next lesson. I'll see you there. We've come so far. This is our last lesson of this course for object-oriented programming. And this is a great way to end the course, as we are going to talk about special class methods only found in Python and only used within a class. These are essentially Python's version of like special forces, or like the Navy SEALs. Let's check out what I'm talking about. What are these special methods? So special methods are automatically ran when an object is created. And this is the same thing that happens with init, right? Because init means initialize, it means start. And init is automatically used and called when we create an object. We don't even think about this, it just automatically happens. These are double underscore methods. Init has 2 before and 2 after. And these double underscore methods make operator overloading possible. Now, I can say special methods, but I could also say Dunder method. Dunder means double underscore method. It's a Dunder method. And these give extended meaning beyond their predefined operational meaning. So you already know one special method, init. We've been using this whole course. So you have a general idea of what init is and how init works. But with Python, we have so many other special methods that we could use. We are only going to take a look at a handful in this course. Once you get a general idea of what they are, how they work, you'll be able to implement your own logic and use new ones outside of this course. Let's check out a few of these now. Here is a list of some special methods. Now the first one I've put as init just to warm things off because you already know that. One is down, right? We use init to build variables for the object. We have a Dunder method called del, and del has the ability to delete an object.
I want you to think about now, how do you delete an object from a dictionary? Well, the same kind of applies for this del method. We have the Dunder method string, and this returns the object representation in a string format. So it takes the object and it turns it into a string. We have the len, or the length method, and this returns the length of an object. We have the equal method, which allows us to compare the values of two objects using the equal sign operator. That's really useful. We then have the addition method, and this allows us to add two objects. You can start to think, if there's an add method, is there a subtract method? Yeah, there is one, and we can take a look at that. There's endless special methods. We're only looking at a few here, and we're not going to cover all of these in the next few slides. But you know that they have them, and in the challenges, I might give you one where you use a method that's not in here. Think about, how can we do that? Where could you learn about that? Let's take a look at the first Dunder method I have, which is going to be a string. This method creates a string representation of our object. It's called by the built-in string function. We have this. This is a normal built-in function that comes with Python, and it's commonly used to define human readable strings. If you want to have information a person can read, we would convert it to a string. You can see I have a class person with init, and then under init I have my string Dunder method. It is returning the name and the age of my object, which is John, 25. When I print my object, it's automatically going to return this to me as a string. So I can construct a string using the name and the age properties from our init, and it'll return a string for us. We create an instance of person. If you try to print the object without our string method, check out what happens. It's not necessarily an error, but it's just printing off literally the word object. Here is how that would look. So everything done correctly with our Dunder string method here, we would get a nice output like this. If we try to print an object without the string method, we would get this. So this is a useful tactic. Great. Now, why do we use this? This string method is helpful for a lot of things. Debugging and displaying object info that's in, very specifically, human readable format. You will see this in code examples as you broaden and strengthen your programming career. Let's take a look at the next example of a Dunder method. Next up, we have the delete method. And this method is called when an object is about to be destroyed. It's used to perform any final actions before the object is removed from the program's memory. So think about any cleanup tasks or actions you may have. Any connections we need to close, anything that needs to be handled before we delete an object. This is why we would use the delete method. Now, it's not actually very commonly used, but it is very useful when you're trying to achieve that goal. And it can be helpful in situations where manual cleanup of your code is necessary. We have our class file within it, and then we have our Dunder method delete. Currently, all this is doing is printing. It's not doing anything very useful, right? But it is being called. Now, to use it, we create our object, and we use the Python del operator, del object name. This del operator is the same operator we use when working with dictionaries and deleting objects from dictionaries. So you should have seen this operator before. That can be used with our del Dunder method. Great. Here is how that would look by calling del on the object
it would call the del method, and in this example, it would say deleting file data.text. Moving on to another new method, our add method. Now this is quite useful, especially when working with integers or trying to do anything like that. This allows objects of a class to be added together. Now really look what's happening here. We have init with two properties, an x and a y. Then we have that special add method. And this special add method is taking one parameter, other. You will commonly see this parameter other. It's like a special keyword or a special parameter used by developers. It's just like with a for loop, for I in range. I, we just use I, we like it, right? So other is the same, and that represents an other object. We then enter that, and we're checking if other is also an object of the same class. So if that instance is the same as my class vector, that's what that line translates to. If our parameter other is the same object or from the same class as we state here, then we can do something. So if yes, we want to add the corresponding x and y components of the two vectors together. New x, new y. We're taking the current x value and we're adding it to the other object's x value. We can then return a new object with the new values. Anything else, you can raise a type error for the unsupported type of our addition. Great. In result, this creates a new object. So currently, before the program ran, we had vector 1, vector 2. Result is actually going to be vector 3, right? We are adding them together and getting a result. This would be the output. Our new object has the values of 6 and 8. Why? Well, remember, we added together the values of our objects. So 6 is 2 plus 4. 8, 3 plus 5. That is giving us our output of what we're looking at. We are then taking the object and linking the properties x and y to get our values of 6 and 8. This is a lot. Okay, if you need to pause the video. Go back to the previous slide, as I find that one incredibly helpful. This one broken down, how I've broken this down. Read that. That's translated to plain English. That helps me a lot when learning, and I certainly hope that that helps you. If we have the addition method, we must have a subtraction method. We do. Our subtraction method works the exact same as the add method. Well, not the exact same. It works the exact opposite as that method. You can see here I have the same code. The only difference is inside here I am subtracting those values, and then at the bottom I am also subtracting those values. This does the opposite, right? So my new object is going to be 2, -4, because 7 minus 5 is 2, 4 minus 8 is -4. That's the value of my new object. If I were to print off vector 1, that gives me 7 and 4. And if I were to print off my result or res, that would give me 2 and -4. All of these are working the same. That's great. This brings us to the final method here, and this will be our equal method. And I included this one as this is actually quite useful, and it allows us to check if two objects are equal. Imagine if you have 10 different objects from a class. Just like in our last lesson's final challenge, we created this e-commerce platform store, and we had 3 products. What if a store had 100 products? You can see how this method could be used to our advantage. We have a class called rectangle, and then we have our equal method inside there.
Now, equal also takes the other parameter, just like with add and subtract. And we can check if the objects are from the same class. And if this returns true, so if the width of my object is equal to the width of the other object, and the height of my object is equal to the height of the other object, then true. It's equal. Those objects, those rectangles, have the same width and the same height. It's going to return true because they're the same object. Now check out how I can use that. I can print and I can take my object and I can use the equal operator with my second object. R1 is equal to R2. That's true. R1 is equal to R3? No, that is false. Python will call this method on the object to its left. So this would be called on the R1 because R1 is to the left of the equal operator. We check if other is also the same object of the same class. If yes, check if the objects have the same width, same height. And if that's true, we can return true, which results in a true output. Amazing. That wraps up this lesson. Now, before you jump into my videos for VS Code, you have a wealth of knowledge now. As in, we started this course, Object-Oriented Programming, with the introductions of objects, the introduction to how to define a class. We looked at class inheritance and then multiple class inheritance. That brought us all the way to this final lesson of special methods in Python. Take the next hour, take the next 2 hours, spend the rest of the day, and try to build classes using all the knowledge you've gained from this course, and try and include a few of these special methods we've learned. I'll see you guys in VS Code. Great, here we are in the first challenge for the introduction of Dunder methods, or the special methods for which we use when working with classes. Diving in, I have worded these challenges slightly different in the explanation to make it hopefully easier or just a different strategy for going through the problem. If we go through these one by one, ideally, we should be creating some pretty cool classes with our objects and our solutions working correctly. In this first one, we want to create a system for checking the different roles within a company. So I'm about to jump in here and I'm just going to define my base class employee with our init. And this is going to initialize the name property and employee ID property. Let's jump over into our code. Up top here, let's create our class, and I will call this employee. Employee is tasked with creating the properties of our name and employee ID. For each of these, we can create those properties. Then we're going to use our string method. As in, what we want to do is, when I print off my object, I want it to print off the employee's name and their ID. So I can do that by using the special string method. And we can return. What do I want to return? Well, I'm going to return a string like employee. Then right here, let's do some interpolation. Let's say our name, so employee name. Very nice. All right, so that is going to return us the employee name and then employee ID whenever we print off the object itself. That's the advantage to using this string method, is we can print an object
and it will automatically return or print something back to us. Great. Moving on, let's create a method to check if something is equal to something else. So we know that we're going to have other, and other is just that special parameter word. You could say anything else, but you will popularly see the word other in here as a parameter. What we want to do is we want to see if two employees share the same employee ID, because that's not possible. And speaking of employee ID, let me add in my parameter there, my value. And to do this, we are going to say if. I'm going to create a condition, and we are going to use the isInstance function. Inside here, we are going to say, is the other person, is the other parameter, is that also an object from my employee class? That's what we need to check first, to make sure I have an object from the same class. If that is, then we can check if they have the same employee ID. If they do, I want to return the value true. So how can I do that in one line of code? I want to return something if it's true. What we can say is if the employee ID is equal to the other object's employee ID, that's going to be true. Else, if it's not true, we can return false, like so. So now I can use this to check first, is the other object from the same class using the isInstance function, and then we are going to return true if they share the same employee ID, which is impossible. That's not allowed. Our last method that I want in this superclass, or this class, is I want the add method. The add method can also take an other. And, well, in this case, actually, I'm going to create this add method, but it's going to kind of raise an error, actually. So I'm going to say raise, and let's say value error. What do I want to say? What do I want to alert the user to a value error? And I just want to say cannot add employees. Right, that's impossible. I can't add two employees because they're not numbers, they're objects. And those objects, those properties, one of them is a string. We can't do that. So I want to raise an error if we try to add those two together. And that can be done by using raise, the Python keyword, and then the type of error. Carrying on, I have my employee class now. Let's make a class for manager. And manager is going to inherit. And I want you to think about, while I'm making init here, what is it going to inherit? Well, the manager, they are still an employee. That's not changing, right? The manager is just the number one employee in that location. So the manager is going to have their own name and their own employee ID, as well as which department are they the manager of. That's important. Let's activate that superclass quickly here and put like that. Perfect. And let's create our property of department and say that is the value of our parameter. Great. Now that we have that all running, we are going to do a few things. Now, each method in this challenge, they're all going to be special methods. And they're to show you what we can really do with those and how we can use these special methods to your advantage. Right? So look at what's happening and think about, in your own projects or your own creations, how could you implement these special methods? The first special method here I'm going to do is let's do another string. And when this is ran, we want to return a few things. So I'm going to give back here like a manager name and a manager ID in their department. So when this is called, let's return, and let's say name, so the name of the manager, And then here we can say like, that manager has an ID. And that manager has a department. Let's just say DPT. Great. There we go. So I'm returning the manager's name, ID, and their department. Next up to bat, let's do the same thing. So I'm just going to bring these down actually. Okay. We have the ability to check if the same employee ID is shared and check if a manager was added together. Okay. And then finally, our last one, right? We have a staff, and the staff can really inherit everything. So I'm gonna take this. I'm gonna take the manager class, and we can just bring that down and put this here. I'm gonna change manager to staff, but it's still going to inherit employee, right? So each class is ideally doing the same thing, but wait until we create our objects to see the interaction between them. So a staff is an employee. Now the staff will not really get a department. Their only difference is going to be a role. So what role in the company do they have? So let's change that to role. Let's say role here. Great, looking good. Cannot add, let's say, staff members. Alrighty. Now comes the creation of the objects and what we really want to do with these. So first up, let's create some employees. Let's say employee 1. And I'm going to copy this because for each, let's create 2 objects. So let's say I have 2 employees, I have 2 managers, and then I have staff. And so we can really see the interaction between these objects. So employee, they are going to be an object of the employee class. And we can just give them, let's say, John Doe. Let's say, what is the other one? Employee ID. He can be 1. Employee 2, let's carry on with that, and let's say Jane Doe. She is going to be employee 2. Great. Our managers, we can give them the manager class, and they also get a name. Let's say Bruce. Okay, they are employee ID, let's say 9. And their department is going to be marketing. Great. Manager 2, they can be Sarah Jane. Her employee ID is 8, and she's going to be head of sales. Our 2 staff, let's say Mark Jones. Let's say Mark Jones is 12, and let's say his role is going to be, he's a marketing ops dev. And then let's say our other staff member, this is going to be Emily Davis. And she can be 14. Her job is going to be software engineer. Now let's use the classes we've built and see how we can use these special methods to our advantage. So let's just go through, and I'm just going to go through and I'm going to print off a few things. So let's print off employee, let's print off manager 1, let's print off staff 1. Right? So these are just objects, but because we're doing string representation with our special string method, we should actually get back some information. While I run my code, okay, so let's go up and fix this. Line 20, where is line 20? Super, let's change this to employee. While I'm up here, let's change this to employee. Alrighty, trash our terminal, run it again. Great, there we are. So the 3 objects I'm printing Employee, I have the name and the ID number. The manager is Bruce, ID 9, Department Marketing. And then the staff is Mark Jones, ID 12, position Marketing Ops Dev. Oh, that's so cool. So we are using that new method to print off our objects, and now we can actually return that value. Great, let's carry on. So now that I've done that, let's check if some of our objects are equal. So I know we have employee 1, and I want to call the equal method on the object to its left, which is employee 1. And I'm going to check if it's equal to employee 2. I can do one more. Ideally, both of these should return false. False, very nice. Okay, they are not equal, right? They are different. Staff 1, you can see these 3 different arguments for each object. They're different. They cannot be equal. Great. And then finally, let's try and add the managers together, right? Because I did include the add special function, and I want to raise an error. Let's go down. Let's say manager 1 plus manager 2. Let's watch the error get risen. Raise, cannot add. Well, okay, if I'm using the add, I should be giving it a parameter, even though we won't do anything with the value of that parameter. Let's create it. Now that we have all 3 of those, let me trash. Let's replay that code. Great, there we are. So I'm still given an error, right? But then we're given our value error right here, right? Our value error cannot add a manager, and that is raising our value error. It was risen. Great, that was the interaction we had between 3 classes. We created one superclass, employee, with 2 subclasses, manager and staff. Each of these classes used the same 3 special methods, and we could see the interaction between those as we created and used our objects at the bottom. Very nicely done. I will see you over in our next challenge. Welcome to our next challenge. I decided to put a challenge together for you sports lovers, as I don't tend to do too many sports challenges. They tend to be about finance or travel, something about that. So here's a sports challenge using our special methods. Now, we will have 3 classes. Each class will be using the same special methods, kind of like in the last challenge. Although instead of using the addition method, you will be using the subtraction method. We will be creating sports teams and using 2 data types as well. You'll be using lists and sets to complete this challenge. Let's jump into our code and start going on our superclass. The first class we want to put together is going to be a generic class for sport, right? Every sport starts with something similar. In this case, it's just going to be a name, and we can build off that name. So let's start at the foundation, at the basics, and let's just create a place for us to store a name of a sport here. So I can create my init, and I will create one property called self.name. We can return a string if we print a sport object. And really, all we can return here is just say this is, and then I guess the name of the sport, self.name. Looking good. Let's actually just create one final special method. And let's do the add, but I'm gonna make it not possible to add one of the objects from the sport class. I don't want that. So similar to the last one, we can raise a type error and say not possible. And then I know in the other ones I'm going to have the subtraction one. So let's just raise an error in this one, as I also don't want this to be possible using our superclass sport. All right, so all of these are very bland, very basic right now. Now we can start to build the other two classes, which are going to start to do a few things. We are going to have a class called football. Football is a sport, we can inherit that, and football has a few of its own details. So besides just a name, which I need to inherit, it's also going to have a team, right? So who is that team? And let's just take our sport class, let's init, and let's say self, name, and then create a team property, like so. When we print an object, so I'm going to create a string representation here. We want to return the name of the team and the teams they match with, or the teams that they have. So how this would look is I could create an f string and I could say this is, we can put our self.name here. Then what we can say is, alrighty, we can check if they are equal. So I'm going to say self, we are going to say other. Do you remember how to check if they're equal? What do we need to check first? Well, we need to check if they're an instance of. Who? Other. What are we checking if they're an instance of? The football class. If that's true, then we can check to see if the values are equal. So we can take the name and we can say if the current object's name is equal to the other object's name and my object's team is equal to the other object's team. That's going to be true. Else, oh, I don't even need an else. Let's just return false. Great. Then the last one we'll do for this one is I included in the task for you to create a subtraction method. So let's use the sub special method. And I am going to have the ability to do something here. So this is going to take a parameter of other. And before we can do anything, we need to make sure it's an instance from the same class. So let's take our other and let's put in football. Now, when this is called, we want to create a list. And this list is going to have team names, but specifically it's going to be a set in a list. And remember, a set is one of the 4 data types or data structures in Python. The other 3 being list, tuples, and dictionaries. A set is used to store multiple items within a single variable. So, seeing that a set is unordered, you can't change it, and you can't have duplicate values, that makes it useful because we can't have duplicate teams. So let's create a list here in a way. And let's say, let's call this shared teams. That seems like it'll work. Let's say it's a list, and then inside the list we're going to have a set. Right? Now this set, we're going to have our self.team, and our other set is going to be other.team, like so. I can then check and I can say, okay, so if I have elements, if I have something in my list, shared teams, then I can do something. Then I want to create a new object from the football class using the list values I've just created. So I can return a new football object. And the team name I'm going to put as an F string. And I'm going to use the team name as myself.name. Like so. Okay, that's working. Then we can say for our other one, let's just say our list of shared teams. And to separate, I'll put like 2 dots. Great. So I'm returning a new object. Else, if that isn't the case, let's return that there's just no common teams. No common teams between them. Alrighty. And then lastly, if that was not true, right, then we can just return, let's say not possible. Kind reminder there. All right, looking great. I am going to do the same thing here for the basketball class. So let's take this. What do we need to change with this class now? Well, let's change everywhere it says football. We are going to give it a new class. Okay. And this can be our basketball class. It's going to do the same thing as the football class. It inherits sport, it has a team, we are checking if the values are equal, and we have the ability to add teams as well using our sets. All right, now that we've gotten through all that, the last things we should do is let's play around. Let's see what these values are going to return. So let's just create a very basic one. So this is the most basic class. This is our super class, right? This is super basic. All right, there we are. If I go through, right, and if I print, and I print basic, what do you expect to see? Well, we expect to see this is super basic. All right, that makes no sense. But if I go up to my superclass, that's exactly what I'm returning. Okay? All right, so we know that works. This is, I'm just going to say super basic. That'll just look better. We have that. Let's create objects from the other two. So let's say football 1, football 2. They are both objects of the football class. The name, let's call them, well, what sport? Is that the name? Yeah, what sport is it? So football. Okay, and then team, I'm actually going to make a list here of teams. I'm going to hard code this for a second. And I'm going to say, well, let's take some football teams here. Let's say the Giants, and let's say the Dolphins. Guys, I haven't watched American football in years, so don't judge me on choosing those teams. Okay, let's say football. Let's say now the teams. Let's say the Steelers. And let's say the Eagles. There we are. So I have the name of the sport and then a list which contains 2 teams. This list is what's going to be passed through here and subtracted against. We can do the same thing for basketball. So let's say basketball 1, basketball 2. They are both from that basketball class. Okay, we have a name again. So as a string, I'm giving the sport of basketball. Okay, and then for your teams, you can give a list again. I'm going to say the Jazz, and I am going to say here the Kings. Okay, and then, our other teams, let's say Golden State. And let's say the Rockets. Brilliant. So we have all of those. Now that we have, let's go through each one and let's just make sure that they're giving us some type of information that we're looking for. So printing off our objects to call our string method. There we are. This is super basic. This is football team matched with teams, Giants and Dolphins. Seems like it's working. Great. Trash my terminal. Now let's try a few of the other special methods. So let's go through and let's say, let's print off. Let's check if some teams are equal. So let's check if football 1 equals football 2. Let's check if basketball is equal to football. What do we think is going to happen here? Okay, let's give it a check. Great. So it is working. Both of these are false. How could I check if one of them is true? Let's think about that. Right? I want to turn one true. What would I need to change if we wanted to do that? We change this and we say like team A in both of these. And then the other team we can say is going to be team B. Now, when I run this, the equal operator is going to evaluate those and check because we're passing those in. And you can see that it's true now. It's true because when I go up, we are checking if the objects are both from the same class, and we're checking if the name and the teams are the same. So it's returning true. Great. That brings us to our last ones. Let's try our subtraction method. So let's print off and let's say basketball 1 minus basketball 2. What can we do here? What is the output going to be? Let's run it. Okay, so we're getting no common teams between them, right? That's because each of these teams is completely different. What if I change Golden State and I now put Kings? There we go. This is basketball. Team matched with teams, Kings. Right? That I'm subtracting. And it found that it's in both of these. Great. Very nicely done on this challenge. Let's move on to our next one. And I hope the gears are spinning. Everything we've been working with here is slowly coming together. You're doing great. We have 2 more challenges left, and I will see you guys in the next video. Welcome back to our next challenge. Give a read through. Now in this challenge, we've done library as a topic for multiple class inheritance. And that really just focused on one product. They had books. Now imagine a company with multiple products. We don't just have books, but if you go to a library, at least when I was a kid, I could get books or I could even rent movies and DVDs. We want to create a few things on how we can handle this together. Now, let's head over into our code and start on our base class, our superclass item. Starting in the code, let's create our class item. Now, everything in the system is going to be an item. A book or a movie, doesn't matter. They're both items. So that's why I'm creating this superclass which will be given to both of those items. Now we need to give it a title and an author or director, creator. So self-name. Great, now that we have those, let's do a very basic return using the string method. And let's just say here what they're getting. So just return and say self.title, self.name is by the director or the author. Great, there we are. So we have an item. Now an item is going to have 2 attributes, a title, that name, and it'll also have an author. Great. Continuing on, let's create our first class which will inherit. So we have a book, and this book is an item. This book is going to have something of its own. So it's not just a title and an author. It's also going to have the number of pages, right? Just like a movie might have the length of the film. So slightly different. Now let's initialize and let's say item init. We are going to say self, we are going to say title, and we are going to say author. Then let's say here, let's create a property for the number of pages. Pages. Great. Now, maybe we want to return the length of that book. This is a bit strange, but let's return
return the length of the book based on the string representation of the length. Let's just use len. We haven't used this one yet. And let's say self. And let's say we want to return the length of self.pages. Right? Because len, you can't really return the length of a number, but let's watch what happens with this. All right, so our book is complete. Let's create a movie, and let's say a movie is also an item, right? Or technically a movie's not an item, so a DVD is, let's say that. This is going to inherit some stuff. Now, we are going to inherit title. That's going to come from the item class. But then a DVD doesn't have an author. It has a director. So let's say director there. And then let's say length or duration. How long is the film? So we have that, which means I can take item. We can initialize item very quickly. And the only thing we're actually initializing here is we're going to initialize our title. But then I'm also going to initialize director, because director and author are kind of like the same thing. Although it's not the same name, that's fine. I'm still going to take that as the second parameter from my superclass. So let's just, for now, initialize director. Then the real new property is our duration. Let's say that is equal to our duration. Okay. What is the length of this movie going to be? Well, let's use len. Let's say return, let's say self.duration. Right, now that we have that, let me clean this up. Okay, looking grand. Continuing downward. Now I'm going to make one final class. Now, really watch what happens here. So I'm going to create a class, and I'm going to say library item. Library item is going to inherit. It's going to inherit book and DVD. So let's say that library book is this X. Book and DVD are those X's. So I have a tree. I just made a tree, okay? Now, if you look at that, everything started with item. So this new class, library book, has access to the class item, even though it does not directly inherit. Library item only inherits book and DVD, but both of those classes inherit item. So I'm passing the item class through other classes for which I can use in this class. That's a new level of inheritance. All right, so in this final class, let's initialize, well, everything. I want access to pretty much everything. I want access to my title, my author, my pages, my director, my duration, and then let's make a new one. How many copies does the library have available? Let's say copies. So I'm going to go through and I'm going to say book init. Okay, now everything coming from book initialize. So title, author, and pages. Everything coming from DVD initialize. So what's coming from DVD? We have a title as well. We have a director this time. And then we have a duration. Great. And then our new one, I'm going to say copies, is equal to copies. Wow. This is a bigger class we're putting together here. So pause the video, just take 2 or 3 minutes to look through this new class we just made. and see how we're initializing everything and how it's being passed down through the classes. This is a really important fundamental concept here. Okay, this last class, all it's going to have, this is going to have a string method and the addition method, which we'll get to here in a second. Let's just start with string. And let's say here for string, let's return an F string. Okay, let's try that. So if I return my library item object, I should get it. The title is by this author, the book is this long, and my DVD is going to be this long. Or do something else creative. How could you use those properties to return something in the string method? Finally, I want to create and use the add method. Now, imagine I have a copy of a book like Harry Potter 1. And then I get more copies of another Harry Potter 1. I want to be able to add those copies together, right? Because it's the same book and I'm adding them to my library. So I'm going to use the add method to do so. So we have other. What do we need here? So if we need to check is an instance of the same class. So if other is from library item, okay? And my current title of the book is equal to the other title of the book. It means they're a match. They're the same object and they have the same title. So, for example, I'm inheriting book and DVD, okay? So this is making sure that either the titles of two books match or the titles of two DVDs match. I cannot add together a book and a DVD. They are different, right? And I can do that because we're inheriting two different classes. All right. What I want to do is, let's say combo again, and I want to have a combination. I want to add together my current copies with the other copies available. That's how I can do that. We can then return a new library item object. I can return here the title of the object, which was the existing title, really, okay? The author is the existing author. The pages, it's still the same number of pages. It's still the same director. All the information is still the same. The only information that is not the same is the final attribute, the number of copies. This is increasing to match the variable we've just added, combo. I'm updating the number of copies by creating this new object. Finally, I'm going to throw an else in here, and I'm going to raise a type error. And I'm just going to say cannot add two different objects together to alert them. Just like a friendly reminder, hey, you can't do that. Amazing. Our classes are completed. We are ready to move on to create our objects. I'm going to go forth here and I'm going to create an object of each. I'm going to say book, I'm going to say DVD, and I'm going to say a library item. So I have one from each we can play with. So let's say book. For our book, let's just say Harry Potter. Okay, our author, we can say J.K. Rowling. And then what else do we need to know here? I'm going to say pages. Oh, I don't know. Let's say 500. So DVD is going to be an object of our DVD class. Let's give it the movie Inception. That was a good film. Let's say the director was Christopher Nolan. Okay. And then the duration of that, let's say in minutes, let's say it was an hour and 30 minutes. Okay, great. And then our final item is going to be a library item. So I'm going to use my library item class. Now I'm going to do really two things here. I need to include so much information. So let's give it a title. Let's say Python course. Let's say I am the author or director.
Let's say how many pages? Let's say 500. It can be a number. I need a director now because I'm creating an object from the library item, which is a bit strange. Okay, I'm going to go through real quick and I'm going to print off each object. Let's give a quick test to that. Okay, so I have been given an error. It's because I'm using name, not title. Okay, so I'm gonna say self.name, inherit that. That makes more sense. Did I use that in other places? Should be good. Okay, there we go. So I have Harry Potter is by J.K. Rowling, Inception is by Christopher Nolan. All in all, everything is working generally how we want it to work. Let's test a few new things out now. So let's print the length of an object. Now, if we did not have the len function inside our classes, like up in here, then great, here we are in our next challenge. Now I've done financial challenges, I've done things about travel. I haven't done one about crypto, so I had to include that one here. What we're going to be trying to build is a cryptocurrency management system. And we're going to make a main base class of crypto and then two child classes of Bitcoin and Ethereum to represent those two most popular cryptocurrencies and their properties. Our code is going to allow users to create new cryptocurrencies, compare them, add them, set prices, and calculate the value of their portfolio. At the end of this, you're going to be creating a mini portfolio and using a dictionary to create objects based on that. Let's head over into our code, which I can call here, and I can just say crypto. It'll be very generic. And this is going to be a very generic class. I can have init, and init is just going to take the name of the crypto. Okay, so let's make our property for that. We can return a string representation, and all we can return for this, because we don't have a whole lot of information just yet, we can just say this is okay. We can check if the objects are equal to, because we can't have the same names, right? Bitcoin, there's only one Bitcoin, there's only one Ethereum. So self other. And here we can check if is an instance. If what? If other is an instance of the crypto class, then we can check if the self.name is equal to the other's self.name. That would return to us true, right? Else we can return false, all right? We can expand on this in the coming classes. I am going to create an add special method here, and I want to have the ability to add two crypto names together. So keep in mind they're just strings, so not too many errors should happen, and I should be allowed to do this. But I do need to check if they're an instance of the same class still. So I can say other, I can say what's my class, crypto. Now let's just create a variable called combo. And this is going to be the combination of my strings. That will be the value. So what do I want to do? I want to add together my self.name. I can say plus, let's say a space, let's give a space, and then we can say other dot name. Okay, looking good. Then let's create a new crypto from this combo name. So I can return a new object. The name will be combo. So I can use that to create a new crypto. If only if it actually worked like that. Else, we can't perform addition. So let me just raise, and I'm going to raise a value error, and I'm going to say cannot perform addition between them. Okay. Next, let's create a method to set the price. So this can take a parameter price, and I'm going to create a property right here because I don't need to define the value when I create my object, only when I use this method setPrice. So I can define it locally inside this method, but because I'm using self, it's a key, it unlocks it for which I can use throughout my class. Let's say I can add my parameter price onto that. Now let's say def, and let's get the price. I have a method to add price or set the price. Now I want to get the price. So the first thing I need to do here is before I can get the price, I need to check if this object has the attribute price. So I'm going to first put in here, what do I want to check? Well, I want to check myself, my object. And I want to see if my object has the price property. So I'm going to say price. If that's the case, let's just return the price. Else, let's just say print off price not set. Looking good. And, how many methods do we have? 1, 2, 3, 4, 5, 6, including init. Let's finish up the superclass with one final method. And down here, let's create a method, and let's just say calc value. I want to calculate the total value of everything. And I'm going to be giving it a quantity. So how much of something do I have? So I'll say quantity. And I can say if we have the attribute, if I, myself, has the attribute of price, then what I would like to do is I would like to return the current price times the quantity that I have. Like so. Else, once again, I can just print off and say price not set. Great. So our superclass is done. That's built. Now, before we create any objects, let's create just 2 child classes. So let's create one for Bitcoin, and we can give that crypto, because that is. For now, let me just type pass. And I will create one for Ethereum, and let's call that also crypto. Or let's inherit crypto, I should say. Great. Now, the 2 classes aren't going to be doing a whole lot. So once I do one, I'm just going to copy its components. But just to give it a bit more functionality for class inheritance using our special methods, let's give init, and oops, I have an extra underscore. So inside init, it's not really going to do anything, right? But we do want to activate crypto, and let's initialize it, and let's just give it a name, because I don't have the property. Let's say Bitcoin. Now, when I create a new Bitcoin, when I mint a Bitcoin, let's say string, and let's return. What can we possibly return? You can be creative here, put something you'd like. Just say Bitcoin is decentralized. Okay. Then let's create a method called mine and create a return statement that just returns something like, oops, let's say mining the next block. Great. I'm gonna copy this, paste this in Ethereum. Just change a few of your attributes, right? So instead of Bitcoin, we can say Ethereum. Ethereum, what do we want to say here? Ethereum uses smart contracts. We can say that. And then instead of saying that, let's say minting tokens. All right, we have our 3 classes done. The really interesting stuff is happening in our superclass.
And then the two children classes, just Bitcoin and Ethereum, a few things here are happening. Now let's start playing around with these classes we've made. So let's create some objects. Let's create some crypto objects. So let's say crypto1 equals class crypto. Crypto2 equals crypto class. We can say Bitcoin. And we will say Ether. All right, so within each of these, right, Bitcoin and Ether do not require any arguments because we hard-coded the name inside the init constructor. So our other cryptos, we do need to put something here. So I will put Solana as a name, and then I will put, let's say, Cardano. Okay. There we have two others. So Bitcoin, ETH, Sol, and ADA. Now, you could print off your objects, right? If I go through and I print off crypto1, that's going to return a string representation of Solana, right? And we can also check, and we can check a few things. So all of the other ones work the same. I can say Bitcoin is Bitcoin equal to crypto2. Actually, let's say crypto3. Let's put in crypto3 here. And I'll do two of these. So I'm going to copy that. So initially, let's say Bitcoin is equal to crypto3, and then we're going to say Bitcoin is equal to Ether. Crypto3 is also Bitcoin. So running this is going to result in the same. So let's change this here. It's missing one required. Let's give it self. Okay, and let's go up to here, and we can also give it self. Great, there we are. So firstly, I'm returning a string representation of this because we are printing off crypto1, which is Solana. And then I'm given true, right? So Bitcoin equals crypto3. That's true because both of those share the same name, Bitcoin. Alrighty, looking great. Let's run a few more tests. So let's just try to add real quick. Let's say Ether plus crypto2, right? I can try and run that. I'm going to turn these off for now. All right, so you have adding, you could have the subtraction special method. Then we also added some other methods of our own, right? We made a get price, a set price, and a calc value. Why don't I take my Ether object and I say set price? So how much is the price of ETH at? I'm gonna ballpark. I think it's at like 1750. So let's say 1750. Then we can print off, right? Now, if I were to print off my Ether object and I say get price, I should be given this. Let's check. We're also adding together Ether and crypto2, which that's not gonna work. Let's just create a hard-coded property up here, and let's say self.price initially is equal to 0. Great, running that resolved that, right? So it is giving me 1750. This is Ethereum Cardano, a cryptocurrency. So that is us adding together the cryptos, right? Because actually, I'm adding together those strings right there. All right, so everything there is working. I'm not going to call every method that we made. You guys can play around with that. But at the end here, let's try something different. Let me create a portfolio. This portfolio can be a list, right? But each element in my list is going to be a little dictionary. So let me just enter this. And let's say each item, each key pair. So my first key pair is going to be crypto, and it's going to be, let's say, Bitcoin, right? And then my second key pair is going to be quantity, and I'm going to say an integer. So how many do you have? Let's say 5. And then let's call the other one. Let's pretty much do the same,
but this time let's say ether, and let's say quantity, let's say 32. If you know, you know. Let's just add one more in here. Let's say our last one can be crypto, and for this one, I think I have crypto 1, which is Solana. Let's say quantity, okay, and let's say 25. Okay. What could I
Congratulations and well done in your endeavors in this course. I'm so proud of you guys. You've made it to the end. Throughout this entire course, we have introduced instrumental concepts in the fundamentals of object-oriented programming in Python. We will use these concepts throughout our entire programming journey, and as we begin to introduce more frameworks and libraries to work together in Python, the understandings and the concepts you've gained in this course will be key in determining how you do with that. Thank you so much, and I just want to take a moment to say thank you for your purchase, as I know it's a big deal when choosing an online class. Stay tuned for any future courses I may have, because they are coming. Well done and congratulations. I'll see you in our next class together.